into the launcher, behind the pig, allowing it to be pushed out of the pipeline. The pig needs to be a tight fit, a good seal on the bore of the pipe to effect a seal, because it is driven by pipeline pressure. It needs a differential in pressure to push it down the pipeline. I mentioned it can be driven by a liquid or a gas, so crudes, refined product, processed fluids such as oils, petroleums, gases of course, and the normal pigging speeds are typically in around about 1.5 to 3 meters per second, so they go along the pipeline at the normal product rates, which is typically in that order, so they move along quite quickly in the pipeline. So as I mentioned before, they're driven by the pigging medium, so whatever's in the pipeline, be it a gas or a liquid. Liquids are much more preferred. Obviously the pressures on a fluid pipeline tends to be a lot lower than gas, which is generally quite high pressure. So typically liquid lines, in particular oil lines in the North Sea, will operate maybe around about 30 to 40 bar. Gas pipelines could be 120 bar plus, so the pressures are considerably higher. That creates some problems when pigging with gas, simply because the compressibility of the gas is such that the pigs will be subject to a series of velocity excursions. So when they come to a bend, they'll slow down, the gas pressure builds up, and they'll fire off quite quickly. It's very difficult to control pig speeds in a gaseous product. It's much more easier in a liquid. A liquid is also a fluid environment, so there's lubrication in there, there's less wear and tear on the pigs, and the pigs generally perform better. Gas pipelines, although you do get wet gas and there will be condensates and moisture in there, tend to be a very dry, very aggressive, very harsh environment. And the components on the pigs that provide the seals are a polyurethane material, so it's an elastomer material. It does have good wear and tear properties, but it will wear out over time, a little bit like your tyres, your rubbers on a car. So the pig's driven by pressure. This is a sketch just showing the cross section of a pig. So you've got sealing elements at the front and the back, which can be a disc or a cup. In this case it's showing a cup, so that's a front seal. This is a rear seal. This is the body cavity, which is open. So the pipeline pressures acts across the back of the pig, and that will drive the pig down the pipeline. What we like to do with the pipeline pressure on the fluid or the gas is allow it to bypass into the pig body cavity in between the two disc packages. So this gives the pig some stability. If the pig's only pressurised on the back end, it will tend to run nose down, so it's being pushed down the pipeline. If we allow the gas or the fluid into the cavity between the disc packages, it equalises the pressure, the differential across the pig, and allows it to run in a much more even state. So the wear and tear across the front and the back is comparable. And a note to consider for later on from a cleaning point of view in particular is, if we allow the pipeline product to bypass through the pig body, this will create a forward flushing action. So we have the gas or the fluid coming in between the disc packages. It circulates around the brushes, which will help with cleaning the brushes and maintaining them and keeping them nice and clean. But by allowing the product to flow in front of the pig, there's one of two things. It will create a turbulent flow at the front of the pig, which will prevent solid debris and mass building up, but it will also allow us to control or reduce the speed of the pig a little bit, in particular in gas lines. So with the high pressure, high flow gas lines, bypass is normally used to reduce the rate of the pig speed in relation to the gas speed. So obviously with a hole through the pig body, the pig will run slower in the gas than the gas is running itself. A little bit of example of the bypass. So if bypass isn't used, the pig will go along the pipeline and the debris will build up in front of it. If it's a wax line, if it's a waxy line, crude oil for example, that has the potential to build up and form quite a large slug, or what's often referred to as a wax candle, and it will reach a point where the friction required to push that candle on the pipeline is greater than the differential pressure available on the pig, so it becomes stuck and you'll effectively block the pipeline. The same can happen with other solid materials, dust, debris and scale and powders in gas pipelines. So if we use the product, the gas or the fluids, to assist with the cleaning, it helps to eliminate blocking the pipeline, and it helps to clean the pipeline, because that gas flow, that fluid flow, creates turbulence in front of the pig, which will keep the debris suspended, keep it moving and mitigate the risk of blocking the pipeline. The worst thing that can happen when you put a pig in the pipeline is you block it. Once the pipeline's blocked, it's effectively plugged, production stops. There are lots of different techniques that can be applied to remove that pig, but if you can't get it out, ultimately it's got to be located and you've got to cut the pipeline section out. So it can be a very expensive operation. It's a very expensive mistake to make, getting a pig stuck in a pipeline. Okay, so that's just a little photograph which kind of demonstrates the jetting head. So this is what it would be doing in the pipeline. So your fluid or your gas would be coming out of the front end and providing a jetting action across the front. The nozzles can be directed to the pipe wall, so you've got a high velocity but low volume jetting action, which can also remove soft debris or wax from the pipe wall as well, but mainly it's designed to prevent solid debris building up in front of the pig. So pigs fall into three main categories. I don't know have you already covered intelligent pigging? Okay, so I'm not quite sure why the introduction to pigging is always after the intelligent pigging, because it makes sense to introduce pigging and the practice of pigging before you talk about the inspection tool, because the pipeline cleaning and the preparation of pigging always comes before the inspection in operation. So I don't know why they insist on putting me behind it. But anyway, so intelligent pigs, fine, we've talked about that. We're going to focus really on utility pigs and specialised pigs. So utility pigs are often called production pigs or fit for purpose pigs. These are already available off the shelf, so there's a lot of different pig manufacturers in the UK, in Europe generally, different designs, different features, but they all follow the same principles, and the standard pigs are all readily available and will suit most operational applications. But when it comes to pipeline preparation for inspection or other activities, or if you've got a particularly bad issue with the pipeline, such as heavy wax build-up, then you need to use more specialised pigs, and you may also need to add some intelligence to those pigs. Sometimes they're called semi-intelligent pigs, and there is a bit of a crossover between intelligent pigs, but ILI, intelligent pigs, always refers to a metal loss inspection type tool. When you talk about a semi-intelligent pig, we're talking about a standard pig or a special pig that's got some additional data technology bolted onto it. And we'll talk about some of these technologies a little bit later on. So examples of the specialised pigs there are 2D waxing tools. So that's designed to remove wax specifically. This one's designed to remove harder scales. And this is a geometry tool. We'll talk about a geometry or a caliper tool a little bit later on. So metal bodied, from a construction point of view, there are polyurethane pigs, but generally most pigs are metal bodied. They're single bowls or fabricated. Single bowls is as the name suggests, smaller diameters. It's just a single bolt assembly with discs on either end and a fixing or fastening at either end. Most operators tend not to use single bolt pigs these days, simply because they don't have the same strength as a body tube. It's a solid bar, so it doesn't have the same strength as a body tube. Tubes are preferred, what we call the multi-bolt design. So you have a body tube with flanges, the polyurethane seals slide over the body ends, and they're fixed on with a series of nuts and bolts. Another common terminology is unidirectional or bidirectional. So unidirectional, as the name would suggest, means it will only travel in one direction, and bidirectional means it can travel in both. The difference between the two is the type of sealing element that's used on the pig. So with a unidirectional we have a cup, with a bidirectional we have a disc. So with a cup, because it's obviously an umbrella profile, it can only be driven in one direction. It will only seal in the forward direction. If you pressurise it on this side, the pressure will just blow over the back of the cups. A disc, it's a solid disc, it's a sheet of polyurethane, that will seal pressure on both sides. So it will be driven in the normal direction. The great thing about a bi-di pig is if it does become stuck for any reason and you need to reverse pig it, you can by depressurising downstream, pressurising upstream, you can push it back the way it came. You can't do that with a unidirectional pig. From an operations point of view, cut pigs or unidirectional pigs are only really used for specialists, or rather not specialists, but used as part of a cleaning program where you want something that's low performance. More and more, most operators, most service companies use the bidirectional disc pig because it can be reverse pigged in the event of it becoming stuck, but also even in its standard form it's a much better, it performs a lot better, so it's a better cleaner because it's a disc action rather than a cup, and I'll demonstrate that. So they're preferred for most operations. So the conical cup was the one that I showed you there. So it's a long flexible section. It only seals the pressure in one direction, but the big advantage with the conical cup is because it's a long profile and it's very flexible, it will negotiate reductions in the pipe bore of up to 25%, which is good from a cleaning point of view, especially if we've got concerns about a lot of debris in a pipeline, and we'll touch on that later on. The top one shows a section through a standard cup. These are fairly obsolete, not very many people manufacture that type of cup these days. It's mainly used on the inspection type tools, so it's a thick section, it provides a lot of support, and it's got a very small sealing lip, so it provides support for the bigger, heavier vehicles. It's not used very frequently on production pigs. The disc design by die is much preferred, so we have what's called a support disc or a guide disc at the front, which is normally just slightly undersized in relation to the nominal bore of the pipe, so that provides support at the front and the rear. Then we have a couple of thinner but more oversized sealing discs which seal, so they're designed to be oversized, be a tight fit in the pipe. And a bi-die pig as standard will normally negotiate a reduction in bore of around about 5 to 8% without any modification. But the big advantage is improved performance compared to any cut pig, and the fact that it can be reversed pig, it's bi-directional. There is a difference in the cleaning performance, as I mentioned, between a cup and a disc. Obviously a cup, because it is a conical section, it's very flexible, and when you get debris building up in the pipeline, it will tend to ride over the top of it, so it can be deflected quite easily. Sometimes that's a good thing if it's part of a cleaning program, a specialised cleaning program, because you don't want to bring out very much debris. But as an operational pig, running it on a regular basis, it's not ideal because it will leave wax or powder in a gas line in the pipeline. A disc, by comparison, because you've got this solid, thick diameter disc, it effectively bulldozes and pushes debris out, so it's a lot more aggressive, as this sketch demonstrates. So there's no lift off. It's very good at bulldozing, it's very good at pushing, but the risk with a bi-die pig is if there's a lot of debris in a pipeline, potentially it's much easier to block it and it's much easier to get it stuck. So with the metal bodied pigs, again, some of these slides just sort of demonstrate the different types of pigs that are available and the different types of construction characteristics off the shelf. So we said single bodied or multi-bolt, unidirectional or bidirectional. I mentioned standard designs for specific applications. So there's brush pigs, there's gauging pigs, there's batching pigs, there's dewatering pigs, whole range, all of which we'll touch on. And these are available, like I say, from a multitude of manufacturers. I think in the UK there's 4 pig manufacturing companies, all competing for the same business. They're all available in ranges from 1 inch upwards, 60 inch and bigger where necessary, and they all have very similar design characteristics. Most pigs that are available off the shelf nowadays are designed to go around a minimum bend radius of 1.5D. It's not such a problem in pipelines constructed in the last 15-20 years, because the minimum bend tends to be 3D, which is good from a pigging point of view. A lot of older pipelines going back to the 60s, they use short radius bends, which can cause problems from a pigging point of view with negotiation, and they do cause problems for the inspection tools. But most off-the-shelf pigs will accommodate that. It's important when you're ordering any pigging equipment to specify as much as you can on the pipeline, the ID, the bend radius and the length and the application to the pig supply company just to give them the opportunity to supply you the best pig for the job. Although you might know what you want, and sometimes we think we know what we want, but sometimes it isn't always the best, and there is a little bit of a, not an onus, but it's good for the pig companies to come back and say, you've selected this pig, are you sure this is the right pig for the job because of A, B, C and D? Maybe you should consider this. And sometimes they're right, sometimes it might not be what you want. So the pig discs and the cups are manufactured from polyurethane, which is an elastomer. You can get what's called solid cast pigs. So these are not metal bodied, they're not multi-bolt, it's just a casting. So it's just a lump of polyurethane with sealing elements on it. Generally available in smaller sizes up to 12 inch. They tend to be used more in refineries for batching and removal of certain products or fluids from one pipeline before putting another one in. They've got a limited life, mainly because it's urethane. Once it's worn down, it loses its optimum performance and it needs to be scrapped. What I should have mentioned with the metal bodied pigs, of course, is you can buy a pig and in service, as the discs wear down or the cups wear down, you can replace them. So you can buy, like you would with your car, you can buy new tyres. Okay, so when the discs wear down, you can buy replacement discs, replacement cups. It's a much more cost-effective, long-term solution. And these things aren't particularly expensive. A 16-inch batching pig will be £400 or £500, and the replacement discs will be maybe £250. So we're not talking about very expensive items. Some of the other pigs that we look at are much more expensive by comparison, but these are quite cheap, fit for purpose. The urethane ones, of course, once they've worn down, effectively they're scrap, they're no good. You can't refurbish them, they just go in the bin to be disposed of. And you can't put brushes on, or you can't add other appendages to them either. Foam pigs. So these are the lowest performing pig of all. From an operational point of view, they're very rarely used. More used as part of a cleaning program for a specific application. The big advantage with a foam pig is it's very, very compressible. A disadvantage is it's very weak, so it can easily tear, it can easily break up, but that's also a good thing. To improve the performance, the bare polyurethane is often coated with the polyurethane foam, which is coated with a polyurethane skin, just to give it a bit more stiffness, a bit more rigidity. It still maintains the same degree of compressibility, and it just means it will last a little bit longer. But again, these are really only a one-run pig, so once it's been run once, it's worn down, it usually goes in the scrap bin. From a cleaning point of view, you can have them manufactured with what's called wire card. So it's a wire that's cast on a cloth and cast into the foam to make it a little bit more aggressive, a bit like a file card. Or you can get them with a grit, so they can be grit coated, so they're abrasive when they go down a pipeline. Often used for pre-commissioning and commissioning phases, and often used as proving tools. So the great thing about a foam pig is because it's so compressible, it will go through big reductions in the bore. And if a foam pig becomes stuck, because of its nature, because of its construction, it's just a foam, by increasing pressures and flow, quite often you can break it up. So there's quite a low risk in putting a foam pig into a pipeline, especially if you think there might be some reductions in bore. Foam pigs are often used for proving the pipeline pigability. So if the pipeline hasn't been inspected for 5, 6, 10 years, or a pipeline's never been inspected since it was constructed, to prove the pigability, one of the first things you do is put a foam pig in there. If it comes out at the end, that's a good thing. If it comes out damaged, that's also a good thing. It can give you an indication of potentially what might be in the pipeline. But the risk is much less for recovery than if you were to put a metal-bodied pig straight in there. You would never ever put a metal-bodied pig in a pipeline that hasn't been pigged for several years, or even in some cases for several months in extreme cases. So these are very cheap. Run them once. They can be used for cleaning a little bit, predominantly used for commissioning work scopes and pipeline proving. Cheap. These things are very cheap. By comparison, a 16-inch foam pig compared to the metal-bodied pig probably cost about £70, £70 or £80, depending on the type. So very cheap. They'll go around anything. Bend radiuses aren't an issue. Mitered joints you don't come across very often, maybe in some older pipelines overseas. So this is a joint which is made up of fabricated or cut pipe sections rather than being a smooth bend. Can be difficult to pig. A big consideration with foam pigs as well is, particularly on receipt and along the pipeline, because the foam is very soft, it will quite easily divert up a branch. So if you've got a branch or an offtake along a pipeline length, unless it's barred, which is something we'll talk about later on, foam will very easily go up it. And when you're receiving pigs, a metal body pig comes into the receiver, it's an oversized barrel, it will stall very quickly, but a foam pig will come in at usually a little bit higher speed, and there's a risk that it can go up the bypass line. So you need with foam pigs to put in what we call a receiving cassette to catch it on receipt, which you don't normally need with metal bodied pigs on receipt. Pipeline spheres, rarely used. They used to be quite common in gas lines for condensate removal, liquid removal in gas lines. Mainly these days they're used for meter proving, so they're used onshore just for calibrating gas meter proving systems. It's basically a hollow polyurethane ball which is filled with a fluid. It's normally a water and glycol mix, and it's inflated, so it's slightly pressurized, and it's a tight fit in the pipeline. An advantage with them is from a condensate removal point of view in gas lines is, as they do wear down, you can increase the diameter by inflating them again. So you can pump them up a bit like a tyre, but they'll reach a point where they'll literally start to split. But again, not used very often these days. You probably won't see them. So those are the main sort of construction characteristics: metal bodied, solid cast, foam, and the spheres. Where are they normally used? So they're really used right across the pipeline's normal life, from construction right through to decommissioning. Lots of different functions, and the functionality is managed by the pig design, the disc type, the cup type, putting brushes on there, putting other cleaning materials, putting aluminium gauging plates on there, which again we'll talk about. So the functions are very varied, and you can select the function for the task that you've got in hand, whether it's cleaning, filling, dewatering, drying, etc. Okay, so when it comes to debris removal, quite often we'll use batching bi-die pigs.
Could you repeat again spheres, please? What's the role of spheres?
Spheres, they're not used very often these days. They were commonly used for gas pipelines for condensate removal. Yeah. But now most operators use bi-die pigs, to be honest. There used to be, if you go back sort of 25, 30 years ago, spheres were common in what was called like an automated system. So you'd have a launcher which was inclined, and you'd maybe put 5 spheres in, and you'd have a control finger. So they could be launched automatically, so they would just roll into the pipe, open the valve, they'd roll down, and get caught up in the flow. But they don't do a very good job at anything else. They're only really used for condensate removal in gas lines. Meter proving is where they're commonly used today. So if you've got an onshore gas receiving station and you've got provers measuring the gas flow that comes in, they'll still use spheres because it's a known diameter. You've got a known pipeline volume over a distance and a known pipeline bore. It's just used to meter the gas as it's coming in and calibrate the gas flow meters. So debris removal and cleaning, lots of different types of pigs which we'll talk about. This is a bi-die pig, so you can see you've got the support disc at the front and at the back, and then you've got the 2 sealing elements here. This is a bi-directional pig, but it's fitted with brushes for improved cleaning. So as well as bulldozing, these brushes work on the pipe wall to scrape off and clean off any wax, scale, pipe hole deposit that might build up, and brush out any loose debris that might be in a pipeline. Again, different types. So this is an older design. It's a cup, a lip type cup arrangement, and you've got what's called a flat spring brush. So you've got a brush on a spring arm. These are a little bit dated. Some operators still use them, but the brushes, because it's mounted on a single spring arm, it will tend to bounce and ride over debris. A better option is a circular brush.
Can I ask a question, please? During the brushing, might it affect on the internal surface of the pipeline? I mean, negative effect on the internal surface.
No, there's none, because the metals that we're using are comparable. Yeah, they tend to be a small wire gauge, usually mild steel or stainless steel, and these bristles are again, this is a pretty crap pig design, because these bristles, you maybe can't quite see from the picture there, but it's a flat section, so it's like 3 millimeters, 0.25 millimeter bar, and it's folded a bit like a hair grip. So as soon as that goes in the pipeline, it's got no memory, it deflects, it deforms, and it'll stay deformed, so it'll tend to just rub or scrape along the pipeline rather than brush, unlike a bristle. So brush pigs of this type will clean a pipeline back to bare metal, but they won't cause any damage at all. There is a consideration on that though, is with flexible risers and the stainless steel carcass. Okay, so if these brushes were particularly aggressive, because the inner carcass is like a corrugated assembly with, if you like, ringed steps in it, so they can potentially cause damage if they're too aggressive. And if you've got a stainless steel riser carcass, the brushes should always be stainless steel as well, because if one of those bristles comes off, then you've got a dissimilar metal and you've got a corrosion potential there as well. So the round wire brushes are much better. So the pig on the right is a much better cleaning tool by comparison, because the brushes are fixed. There's no bounce, but if the wires are round, or if you've got a gauge, you can select the wire gauge to make the brush either softer, like an internal, like a house sweeping brush, or more stiffer, like a yard brush. So you can control the aggressiveness of the brushes with round wire quite easily on the circular brush types. If you've got an internal coating in the pipeline, so if it's epoxy lined, for example, wire brushes, steel brushes do have a potential to cause damage. In those applications you would use something like this, which has got a nylon bristle. So it's still a brush, but it's a much more softer material. Yeah, so it's nylon, it won't damage your coating. This is the pig on the other side. Again, these are a polyurethane block. Instead of it being a brush, it's what's called a plough blade, and it's designed to scrape and shear wax off the pipe wall. Sometimes they're effective with soft wax, but they're not very good at removing hard wax. So again, it's a variation on a brush type design. So under normal circumstances, metal brushes don't cause any problem unless it's internally lined or coated. Magnetic cleaning. So the brushes are great for cleaning debris, sweeping it out and brushing it off the pipe wall. If you've got ferrous debris in there, then we often use magnetic cleaning pigs to pick up that metallic debris, and that can be bristles. So these are like bristles that have come off cleaning pigs or inspection tools. You've got some construction debris in there, boards. That's a great picture, but I'm pretty sure somebody's just thrown that on there to make it look good. In reality, a piece of metal that size with that type of pig would get pushed out in front of it. You know, it wouldn't normally ride over it. But so what you have is you've got a series of magnets, usually quite small, that are mounted around the pig body, and they're just designed to pick up any ferrous debris. From a construction point of view, it might be things like welding rods that have been left in the pipeline, packing pieces, lunch boxes, hand tools, this sort of thing. Magnetic pigs, cleaning pigs, wouldn't normally be used as part of a production cleaning program, because the line's pigged on a regular basis, unless you were to carry out some intervention work like hot tapping, where there might be a possibility of having metal cuttings in the pipeline, then you'd use a magnetic cleaner. But under normal circumstances, it's a commissioning type tool. Some inspection companies will insist on running a magnetic pig before an inspection, regardless, just to mitigate any damage to their tool, because if there is a lot of welding rods and bits and pieces in a pipeline, you can imagine with the sensors on an inspection tool, metallic debris can cause damage, but it can also affect the accuracy as well. If you've got ferritic build-up around the sensors, it can give you significant inaccuracies in the inspection data. So a lot of inspection companies will insist on a magnetic cleaning pig run beforehand, just to ensure there's no metallic debris in a pipeline.
At the time of launching this magnetic pigs, is there any precautions at the launchers?
No, the magnets. Did you talk about MFL inspection tools? So our MFL inspection tools have got big, high power, real high strength magnets. These, by comparison, are much lower grade, so they're just typically often just a hard ferrite magnet or sintered neo-iron boron. So it's nothing exotic, and they're relatively small, relatively low strength. Some pig manufacturers will advise that there's a warning of magnets. So if you've got a pacemaker fitted, for example, you would need to be careful. But they're not very, very high strength, not like the inspection tools. On some of the higher performance magnetic cleaning pigs, they'll sometimes put a metal plate just to limit the magnetic field strength, which has got to be removed before you put it in the pipeline. But there aren't any, apart from the weight of the thing, and to be aware that it could have an impact on anybody fitted with a pacemaker, then that's the only real concern. And your procedures as an operator should cover that. The pig manufacturer should also advise accordingly on that, but it should be caught and captured in procedures. It can also, obviously, could affect your watches and credit cards, I suppose, is the other thing, if you're too close to them. But they're not, to be honest, the strength of the magnets on standard pigs is not really high enough to cause any real risk. So pipeline gauging. Gauging is an activity that's carried out often in the commissioning, pre-commissioning stages, and often ahead of an inspection run. So the pig is fitted with an aluminium disc. Often this disc has got radial slots in it to make it more flexible so that it will deflect if there is a reduction in bore. And it's normally sized at a certain diameter, and it's just used to confirm the minimum clean bore through a pipeline. So when a pipeline is normally constructed, before the operator takes it over and commissions it, the subcontractor will often be required to run a gauge plate of 95%, and that gauge plate must come out clean. If it comes out with damage on it, then the operator will have a concern that the pipeline may have been incorrectly laid, there's a potential for some buckles, there's some damage in there. It just gives the operator confirmation that the minimum bore is within a certain parameter. There are other tools which measure it much more accurately, geometry tools, which we'll talk about later on. So for filling and dewatering, again, that's mainly a commissioning, pre-commissioning tool, so it's fitted with multiple discs, and this will be used ahead of bringing product in. So before you produce oil, you'll put these types of pigs in. It's just used to push air out and bring the production fluid or gas on and evacuate air out. When it comes to dewatering, that's obviously post-hydro test. These sort of pigs are used to remove any liquids that are in the line prior to, again, bringing on the product. Drying. Foam pigs can be used for drying purposes. So after a pipeline is constructed, it'll be hydro tested. So it's filled with water normally, and it'll be hydro tested. That water then has got to be removed. So you'll use a number of the filling and dewatering pigs, pig on the right, to bulk remove the liquid. Then you need to get the residual water, residual moisture out there, because quite often an operator will want a line to be of a certain dryness or a certain dew point. So foam pigs will often be used just to simply swab, so to blow them through with air quite often, sometimes nitrogen, but mainly with air prior to doing a vacuum dry or a hot air dry, just to mop up any residual water. Separation and batching. So spheres we mentioned earlier on for meat proving. It's worth pointing out they can be used often in the food industry and in multi-product pipelines for separation and batching of dissimilar fluids that are used in the same pipeline. So if you go to a processing or a food factory, you might have a pipeline that's doing tomato sauce one week and HP brown sauce next week. So it's the same pipeline, you just put a pig in to provide a barrier between the two dissimilar products and also evacuate it out. Condensate removal and meter proving for the spheres we mentioned earlier on. That's really the only use for them. So production cleaning, yes, we use these types of pigs on a regular basis. We also use them for pre-inspection and more specialised or enhanced cleaning operations. We'll talk about these ones in the bottom and in the right a little bit more detail. So this is a fairly standard cleaning pig that we looked at earlier on. The pig on the right has got much more stiffer, much more heavily denser populated brush pack, so this is a more aggressive cleaning pig. And the pig on the bottom here, this is a dual module pig that's designed specifically for wax removal. So this pig, just going back to your comments actually, there are a couple of de-waxing pigs and de-scaling pigs that are very aggressive, and if they're not correctly sized and they're not operated correctly, usually by the subcontractor, then they could potentially cause damage to your pipeline because they are very aggressive in their nature, and I'll show you some examples of those later on. Okay, so that's pigs, the constructions, various types and where they're used. Just carry on.
For separation and batching pigs, how would you receive the pig, and any issue with the product that's coming behind the pig?
Yeah, it'll depend on the particular process setup. So they'll have various valve stations, so they'll divert flow down particular branch lines by valve control. And when we talk about dissimilar fluids like that, it tends to be quite small bore pipelines. So these are sort of anywhere sort of from 1 inch up to maybe 10 inch, so relatively small pipes. So there'll just be valve manifolds which control and divert the flow before the pig's received. And there's a certain type of valve which can also receive a sphere pig, so you can pig it into the valve, turn the valve, and then the pig's effectively retained until the next time you want to use it. I-tag valves, it's worth having a look at. Okay, so considerations for pigging. Yeah, when you're selecting a pig to do a job, there's a certain job that you want it to do, but we've kind of touched on a few of these points already. There's certain things that you need to consider. Obviously, you need a launch and receive trap. If you haven't got those, then you need to look at making modifications, and because you need access to the pipeline, you need to be able to put the pig in, and you need to be able to recover it, and you need to be able to put it in and recover it safely. Okay. Bend radius we touched on, so you need to consider the minimum bend radius. Less of an issue in pipelines built in the last 25-30 years, but old pipelines, it can still be a problem, and it's always a good idea to specify the bend radius when you're ordering or selecting pigging equipment. Pipeline tees, we'll talk about tees in the next couple of slides, but again, you just need to be aware of the tees and the branch size in particular. The branch size could affect the sealing ability of the pig, and if you've got multiple tees together or offtakes, there's a risk that the pig could stall, so you need to be aware of the positioning and the size of the tees. Valves, obviously, reduced bore valves, you need to be aware of any changes in diameter. Certain types of valves aren't piggable. Again, there's a couple of slides on those after this. Y pieces, it's not uncommon to have tie-ins which use a Y, so Y needs to be considered from a pigging point of view as well. The length of the line, so the material selection could vary, and the pig design could vary a lot between a pig that's going to be used in a pipeline that's 10 kilometres long compared to one that's 600 kilometres long. Variation in the internal diameter, and of course the type of debris that we're trying to remove. So the bends, we talked about the difference in bends. Most pipelines today are 3D and above, so it's less of an issue, but historically, if you've got short radius bends, there is a risk if you don't select the right pig, or the pig's too long by design. When it comes to the corner, when it comes to the bend, it will stop, it will stall, it will get stuck.
So how are you going to get it out?
Well, first of all, you've got to find it, and then if it depends on how it's stuck. If it's not bi-directional, you can't reverse pig it. There's lots of different things that you try, so increasing the pipeline pressure to try and force it through. Cyclic loading. If all else fails, you've got to locate it and cut the pipeline. So you've got to shut the pipeline down and cut it, remove it, put a new fitting in. We once actually, just on that note, I worked for PII quite a few years ago on the pre-inspection cleaning side of the business, and we were in, I think it was Nigeria, I can't remember, it might have been Nigeria, I can't remember. But we were pigging the pipeline, foam pig had gone through it, no problem. We went through the development stages and we put a metal bodied pig in it and we were tracking it, and it got stuck. And And we found it, we located it because it had a tracking device on it, so it's a transmitter which you can follow it above ground. So we found it, we were looking at the pipeline P&IDs, and the operator said it's a bend, it's a 5D bend, it's not a problem, the pig can't be stuck here. So we said, well, it is stuck. Tried everything to remove it, couldn't remove it. In the end we had to excavate it to dig it out to break into the pipe. And what we found was it wasn't a bend at all, it was a T-piece. So when it was constructed, they'd not put a bend on, but they'd put a T on and simply blanked off one branch. So there was no way, it was impossible to pig it. But the foam pig, because the foam's very flexible and very spongy and soft, went through. So, but that pipeline was probably built in the 50s or 60s. You wouldn't see that today.
And in that case, who needs to pay for the consequences?
In that case, the pipeline operator, the owner, because the information that was provided was incorrect. So the pigs, the cleaning program and the inspection program was correct in line with the data that was presented, but because the bend wasn't a bend, it wasn't our fault. But usually the inspection contractor or the pigging contractor, it's always their fault as far as the operator is concerned, until they can prove anything different. And with the inspection companies, there's often issues with inspection. So when you're doing a pipeline inspection, MFL or UT, it's got to be clean. It's got to be much more cleaner for ultrasonic inspection than MFL. And quite often, inspection companies, when I worked for PII, they used to do their own cleaning, which was fine. So they were responsible for the cleaning. Then they moved away from doing their own cleaning to using subcontractors. So if you have a subcontractor for the cleaning and one for the inspection, if the inspection fails, the first thing the inspection company says it's failed because the line is too dirty. And the cleaning contractor says, no, we cleaned it and there's no dirt coming out. So then you get into a battle between the two companies of who's responsible. The inspection's failed because the line's dirty, but he's saying it's clean, he's saying it's not. So, who covers the cost there? But today there's technologies that can prove a line is clean before you do the inspection. We'll talk about those. So pipeline T's I mentioned briefly. The sealing length of the pig is important when you're crossing a T, especially if it's an equal T, because there is a risk that you get bypass and the pig would stall. Equally, if you've got two T's too close together, you can get bypass around the pig and it'll stall. So stalling just means it just stops in the pipeline. You've still got flow, the pipeline's not blocked or plugged, it's just that the pig has stalled. You can increase the flow to move it or put another pig in to push it out. But your other pig needs to be size corrected so it doesn't stop. We talked about the bars, the T's being barred. So in simple terms, it's just a welded crisscross arrangement that goes in the branch to prevent anything going up it. So metal bodied pigs is not usually a problem, but a barred T is something that you need to ensure that you have in place when you're running foam pigs, for example. Otherwise the foam pig will try and go up that branch potentially. Barred T's can cause problems to some of the inspection companies, because over time with the older pipelines the welds corrode or the bars corrode, and quite often they can drop down into the open area of the pipe bore, which can cause quite a bit of damage to inspection tools, and it does also create a bit of a risk of getting pigs stuck. So valves, there's a few valve types. You don't really see these on pipelines, to be honest. Most valves are full bore valves these days. Quite often you'll get reduced bore valves, but pig design is such that they'll easily negotiate reduced bores to your valves. As long as the valve, the transition is tapered and not stepped, and that goes for any pipeline change in diameter. If you've got a change in diameter from pipeline or fitting from one to the other, it doesn't matter if it's 5 or 10%, as long as it's ground or machined into a concentric taper rather than being a stepped change in diameter. So just a few common sense really on the valve side of things. But you won't see anything other than a ball valve in place these days. So wide pieces I mentioned earlier on. These are wide pieces where you've got two pipelines coming together. There's a number of wides in the North Sea. They can be pigged, but they can only be pigged in one direction, and because of the length of this open area here, you've got quite a large area which is open, so it's difficult to seal across the wide piece, so you need a much longer pig. If you make the pig longer, then the risk is it's going to get stuck in the bends. So to accommodate that, they're quite often articulated. So it's made up of two modules, and then you've got an articulated joint. So it's got the ceiling then, sealing the white piece, but when it comes to a bend, it's articulated, so it'll just bend. Just got a knuckle joint in the middle. The positions of fittings from that T drawing, back-to-back bends or bends that are very close together, even if the tool is designed to go through that particular bend, can sometimes cause problems. So normally the recommendation would be there's a minimum of 1.5 times nominal diameter between pipeline fittings. If you've got two bends simply welded back to back, then that can create a problem from a pigging point of view. Even with current modern up-to-date designs, it causes big problems. Some people might refer to S-bends, where you've got two bends back to back. There should always be a short section or a puck piece in between. Multi-diameter pipeline, so pigs will accommodate a change in diameter, generally sort of 5 to 8%, no problem, with very little modification. But you do obviously get multi-diameter pipelines now, so you might have a 12-inch line that ties into a 14-inch line or a 16-inch line, and it's a continuous pipeline, so you might have multiple diameters rather than multiple bore changes. And again, most pipelines can be managed 16 by 24, 12 by 14, so there are some big step changes out there. The pigs that are used for the larger diameter changes are very specialised, obviously, and they need to be designed specifically for that particular job.
Excuse me, how much money would it be cost to rent a pigging company?
To rent a pigging company,
Yeah,
well,
just invite them and
yeah.
one wants a pig.
Well, they normally charge a day rate, so
Just that, approximately.
they'll probably charge you about anywhere between £500 and £900 per man per day. So
Per man per day.
yeah, so £1,500 per day plus the mob and demob costs, and then
And the lens, yeah.
the rental. Well, yeah, I mean if so, for
Is it
example,
is it profitable to open a pigging
Yeah.
company?
oh yeah, yeah, oh yeah. There's lots of pigging companies. Halliburton is probably one of the world's biggest companies. Yeah, so Halliburton do a lot of pipeline pigging, commissioning works. They also do operation work. So someone like PII, I don't think PII do their own cleaning, so they'll have a subcontractor or the client. If the client doesn't do their own cleaning, they'll bring a subcontract company in. So that subcontract company would be responsible for building the cleaning program. So they'd identify what types of pigs will be used. They'll identify the run frequency, so the proving pig, the gauging pig, this cleaning pig, that technology, this technology, and they'll provide all the equipment and they'll provide all the people. And that could be, as a ballpark figure, the cost of a cleaning scope before doing an inspection would probably be somewhere between 45 to 60, 70,000 pounds. An inspection run in the same pipeline would probably be around about 120,000 pounds. So the cleaning, the running of pigs can be quite a big part of that cost. But with the inspection, yeah, of course, there's a big cost. There's a big cost in the inspection room because you're paying for the data that they're requiring, you're paying for their expertise, but you're also paying for the rent of a multi-million-pound tool. I mean, one of the inspection tools, typically they might cost £750,000. Yeah, oh yeah, very expensive, very, very expensive. Yeah, yeah. And they won't sell you them, they'll just rent them. Okay. So the length of a pipeline is a consideration as well. So most standard pigs are good for up to sort of 150 kilometres, but as lines get longer, you need to think about high performance urethane, so material that's going to wear longer and be a bit harder, and things like suspension wheels, so the addition of wheels to reduce the bearing load and allow the pig to run further. This particular pig here, this was designed for the Yarcheng pipeline, which I think might have been a 36-inch pipeline, but it was almost 700 kilometres long. So that pig ran 700 kilometres in a gas line. Yeah, and it came out in one piece, and that's the pig that they run on a regular basis. So The other consideration, of course, is the type of debris that you're trying to remove. So if you're trying to get out ferrous debris, metallic weld rods, etc., you need a magnetic cleaner. A brush pig will sweep it out, but a magnetic cleaner will pick it up better. Brushes are good for dust, they're good for soft wax, they're good for any sort of loose debris, powder, particulate, loose scale. For harder waxes, then we need to use more aggressive brush type cleaning pigs with discs, or we use more aggressive specialised cleaning pigs, which we'll talk about in the next few slides. Hard wax, hard scale is difficult to get off the pipelines, and none of the pigs that I've shown you there really are any good for hard wax or hard scale problems. Descaling pigs are the type of pig which can damage a pipeline. You'll see how aggressive they are in some of the slides. And then dual modules. I showed you the dual module pig going through the Y piece, but again, from an operations point of view, if you know you've got loose dust or debris in a pipeline that is ferritic, then instead of running a brush pig, then running a magnetic cleaning pig, you can join them with an articulated joint and run the two types of pig together. So you can have a brush and a magnetic cleaner joined together. So it's one pig run instead of two. Saves time. But some operators, even though the pigs are fastened together with an articulated joint, some operators will not run two pigs in the pipeline at the same time. So,
Excuse me, how you can know that the wax is very hard in the pipeline? In order to choose aggressive pigs or just normal pigs?
well, there's a lot of background to that in it. You'll have an understanding of the pipeline. So at the front end engineering stage, when you're looking at the welds and the products and the expected product makeups, you'll have an understanding of whether it's going to be a wax, hard wax, soft wax. You'll have an expectation on the wax content. As the pipeline becomes operational and you run pigs, then you'll see, if you're running pigs on a regular basis, you might get soft wax coming out. When you come to do your inspection in 5 years' time, your inspection data might be poor and it might indicate that there's wax build up. And by flow analysis, there's lots of software programs and systems that are available today, Olga for example, which will, based on a wax, on a crude of a certain density, of a certain specification, operating at a certain temperature over a certain length, they can calculate the wax fallout over weeks, months and years. So there's a lot of modelling now that we can use, but then there's also a lot of technologies that we can put in the pipeline to confirm that as well. So there's a tool which I'll talk about later on, which tells you that there is debris in the pipeline, and it can differentiate between soft and hard as well. So there are technologies that are available to do that. But usually it's an expectation from the commissioning days. You know if a crude is going to be a heavy wax, and if it is, if it's running at a certain temperature, if it's not heated or whatever, then you know you're going to have problems potentially with wax.
Depends on the content of the oil, yeah?
Yeah, and obviously it's same with gas as well. So if you've got a gas pipeline, from analysis of that product, you'll know that there's a certain amount of moisture content in there. So from that you can work out that there will be potential for corrosion, so potential to create black powder, or it might also have a percentage of sand in it. So, if it's got sand of a certain particulate size, if that pipeline's operating for 15 years with 0.001% of particulate in it, if it's not pigged for that 15 years, how much of that sand is likely to fall out? So it can be calculated, but then when you're running pigs will bring that debris out and they'll confirm it, but there are other technologies that can be used to measure it as well. So it's a lot of different practices. Yeah. Okay. Crack on. So yeah, we'll cover that in a little bit more detail as we go along. But obviously, when you're selecting your pig, you need to be aware of what it is you want it to do. Do you want it to remove soft debris? Do you want it to remove wax, hard wax or soft wax, scale, loose scale, powder? Do you want it to just bring out water? So there's lots of things, and every pipeline's different, so it varies and it can vary from field to field. I worked for TACA for a number of years, and we had one platform, Comet Alpha, which takes oil from multiple fields and multiple lines, and we had to run different pigs in the pipelines because the oil had different wax contents, and you were having products from somewhere else, so you're getting product which was co-mingled, so you might have a light wax mixing with, sorry, a light grade oil mixing with a heavier grade oil, which meant that that pipeline had different problems to manage with wax removal compared to another line where the crude was much less, much lower paraffin or wax content. So yeah, all pipelines are different. We need to consider them individually. We need to look at the pipeline features, so the bends, the valves, anything that might prevent or inhibit the running of a pig through the pipeline, the pigability as we call it. What it is we want the pigs to do. Standard pigs off the shelf, so the utility pigs might not be suitable. You might have to look at more specialised pigs, more aggressive pigs, more specialised materials. Something that's not mentioned on there, high temperature is another consideration, of course, with the urethanes. So standard urethane is good for maybe 60 or 70 degrees, but if you've got a pipeline that operates at high temperature, you might need to consider alternative materials to polyurethane, like rubbers. And you also need to consider the volume and the type of debris that you're going to remove. So again, before we start pigging a pipeline, if it's a pipeline that hasn't been pigged for a long time, there's a proving process, but it might well be worth doing a flow model on that before you start thinking about pigging. So if you know it's a waxy product, then if it hasn't been pigged for 25 years, you can look at the theory behind how much wax might be in there, you know, and it could tell you that there's 25,000 tons of wax or 2 tons of wax, you know.
But the company might heat the pipeline and the wax.
Yeah, some pipelines are heated and insulated, yeah. If they're not heated, often they're insulated to keep, obviously the export temperature is quite high, so depending on how long the pipeline is and where it is in the world, it will cool at a certain rate along its length. So again, where it's really hot, there's very little wax fallout. Where it's really cold, there's a lot of wax fallout. So you know, it could be nice and clean at this end, but the wax could be a big problem at the other end, and that's again something that these technologies tell us and demonstrate. Okay. So why clean a pipeline? It's very much like our own system of veins and arteries. You know, if you go large at McDonald's 5 nights a week or whatever, then you know cholesterol's going to build up, fat's going to build up, those little arteries get smaller, and the old ticker finds it a lot harder. So over a period of time, it's going to pack in. It's the same with the pipeline. You've got a pumping system ultimately, and you've got a pipeline that's transferring that fluid or that product. And if the pipeline bore reduces, then you need more effort to pump the same amount of fluids or gas down it. So ultimately, it's a nice little analogy, but from an operator's point of view, it's a massive investment, so we want to keep it clean to ensure continuous operation. We want to maximise the throughput, so get as much product through there, gas, oil, whatever it might be, at the lowest operating cost. We want to keep it clean because we don't want foreign objects in there, because that can cause potentially corrosion growth. We want to get deposits and solids out that might restrict the flow, because again that impacts on the production costs. And then we also want to remove anything that might cause corrosion growth. Here's some photographs of some pipelines. So that's scale build up in a pipeline. So you can see it's quite have a big impact on the pipeline, and this is debris that's been removed as part of a cleaning program. So there's a pig pushing out soft wax. So you know, it can be quite a nasty environment. This is scale that's being pushed out of a pipeline, so these are more hard pipe wall deposits. That's a foam pig that's gone through a pipeline that's got a lot of scale in it, so you can see the foam pig's come out, but it's sustained quite a lot of damage. But that tells you that the pipeline's pretty rough inside, and that helps you decide how you're going to approach the cleaning and what type of pigs you might want to use. So, you know, this type of debris, it's not uncommon. You come across it all the time, and some of these volumes can be difficult to manage. Environmentally, they can be difficult to handle. There's lots of considerations. And from an inspection point of view, you can see here, this is an inspection tool. It's become so clogged up with wax that it's affected the sensors, so that inspection will have failed because of the amount of wax or the dirtiness of the pipeline. said before, an inspection run, it might be £100,000. If that's my inspection tool, it comes out like that, I'm going to say to you as the operator, sorry, we're not going to get any data because your line wasn't clean enough. It's cost you £100,000, I'll run it again, and that's another £100,000. You know, so it's important to make sure it's clean. And the same with this tool here, you can see this is a debris mapping type tool, so the wax is built up around the sensors. And the wax build-up will impact on the quality of data that can be acquired, that's collected, and it could ultimately result in a failed inspection. So it's very, very important to clean it. And again, you know, this picture on the bottom right, just indicative of this was a job offshore. I think that was in I think that might have been in the Middle East somewhere. But you know, significant drums and drums and drums, big volumes of dirt and debris can come out of the pipeline. So it needs to be managed. And then, yeah, this is construction obviously, but you know, as part of construction, they've come back to the pipeline. It's full of snakes, and this one had an alligator, big crocodile down it. Yeah, the best story I heard from a commissioning point of view. So the commissioning stage is the pipeline's being constructed, it's all welded up, and it needs to be hydro tested before the product's brought on, before it's commissioned. So as part of the pre-commissioning phase, it was a pipeline. It was in America, in the US, and apparently it brought out a donkey. So this it was T.D. Williamson. So as part of the pre-commissioning, when they came to bring the first pig out, there was a dead donkey. So the donkey had obviously gone into the pipeline whilst it was being constructed. During the night, walked down it, and then the guys had come and welded it up.
Was it alive?
No.
They had the donkeys.
Yeah. So. So this is just a little example taken from a rule of the pipeliner's rule of thumb, which is it's a kind of like an operator's in construction handbook. So obviously, for a given throughput and for a given operating or production cost, if your pipeline's nice and clean, no change to throughput, no change to the cost in producing or maintaining that flow, your operating cost or your pumping cost, let's say. If you get a 5% deposit, which is relatively small, relatively smooth, that will result in a reduction of throughput of up to 10%, but to maintain your original throughput, you're going to have to increase the pressures and your flow rates by up to 30%, so your cost is going to go up quite quickly. And if that deposit is uneven due to frictional loss and turbulent flow, your operating costs could increase quite significantly. So the importance of a pipeline being clean and the bore being smooth makes a big difference. It does make a big difference. And most operators pig on a regular basis. So once they've done an inspection, once the pipeline's been cleaned to the level it needs to be, most operators in the UK will run pigs on a fortnightly or monthly basis because they want to maintain this. They've spent a lot of money getting it clean, so they don't want to go back to that. So they'll run a pig themselves. They don't bring companies in. The operator will have guys that will just run pigs once a fortnight or once a month. So they maintain the level of cleanliness that's been achieved. And they do that themselves. When it comes to get inspected again in 5 years' time, they might increase the frequency and do a small enhanced cleaning program themselves, or they might bring in a specialist subcontractor just to do a pre-inspection cleaning program. But most of them do a lot of cleaning themselves now. So just an example of that. This is going back a few years, but it's a nice example. 36-inch pipeline. It was in Libya for safety. Okay, so the pipeline was to be inspected, but it had to be cleaned first. Normal throughput was 3,120 barrels. The pipeline was cleaned and it was inspected. Through doing nothing else, the throughput increased by 120 barrels per hour. And even at today's $50 odd a barrel, that's a lot of money for nothing. So a small investment from a cleaning point of view can make a big difference in the revenue generated from improved or increased throughput. And of course it means the operating costs are kept down too. So the benefits sort of speak for themselves really. With regard to inspection and the cleaning and all the rest of it, we're looking at this. So a pipeline needs to be cleaned from a corrosion point of view to ensure that inhibitors, biocides that are put in there hit the pipeline and clean and keep the pipeline in good condition, get a good inspection. But from an operator's point of view, if I put my tacker hat on, ultimately we want to get as much product through that pipeline for the least operating cost, and by keeping the line clean, we can do that. Okay. Questions? So, if we look at production pigging, a lot of this we've kind of touched on, and this really just goes into some of the technologies that are available. So when we look at a production pigging program, we need to understand the history, what's been done, what's currently being done, before we can apply a method or an approach to the cleaning. We need to establish whether it is clean or not, whether there's a problem. We need to implement a cleaning program to get it to clean to the standard that we want it to get to, and we need to maintain that cleanliness, and we want to monitor. We want to monitor it as well. So if we look at those stages, when we come to review the pigging history, okay, so we look at the previous pigging history. If it's got the type of pigs that have been used, run reports. So what type of debris has been recovered, what volumes have been brought out, has any analysis been done, is there any flow modelling that we can refer to, what information, how much information has the operator got that can give me some confidence about how clean that line is. The more information that we have on the background to its operation is, the easier it is to determine how to clean it and what to do next. So if we don't have all of the pipeline details, the configuration, the PIDs, then we need to start thinking about how we're going to prove the piggability and how we can acquire that sort of data. So there's a couple of tools, common tools that are used to give us some of that confidence before we start selecting a cleaning program and looking at certain types of pigs. So the base one is a geometry or a caliper, sometimes referred to as a caliper, sometimes referred to as a geometry survey. We'd first off need to prove the piggability of the pipeline. So if we haven't got any of that background information, we'd go back to square one, we'd get a foam pig of a certain density, we'd put it through the pipeline and see that it comes out. If it comes out in good condition, that's great. Then we'd probably put in a higher density foam pig that. If it comes out in good condition, good. Then we'd use another high density foam pig and put an aluminium gauge plate on it. So the gauge plate would be sized to suit the caliper tool. So the gauge plate, if you remember, is used to confirm a minimum bore. So if we put a gauge plate of a certain size on a foam pig, and put it through a pipeline and it comes out in good condition, then we can be confident in putting a metal-bodied pig in if we know that it will negotiate the minimum bore that gauge plate has told us. Caliper tools are very good at negotiating small bores, so they can generally, depends on the manufacturer, but they'll negotiate reductions in bore between 25 and 50%. So these tools, although they're a metal-bodied pig, they can accommodate some big changes in pipeline diameter, and it's designed to do that. Okay, and it's also designed using, generally speaking, conical cups, because you don't want it to be effective at cleaning either, because at this stage we might not really know how much debris or what potential there is for wax or scale in that pipeline. So to give us the information that we need, we'd use a caliper tool. So it's a conical cup design. It's very good at negotiating small bores. It will tell us where there's any variation in diameter, so ovality, any dents, all the way along the length of the pipeline, any diameter changes, the bend measurement. So that will give us all of the background information with regard to the pipeline configuration and give us the confidence to move on to the next stage. It'll show us where things like branches are, where offtakes are. This tool measures the linear distance as well, so it's fitted with odometers. There's lots of different types of caliper tool. So it's got an odometer, so that measures the linear distance. Normally there'll be two or more for contingency. And then generally speaking, they're all of a similar arrangement. So they'll have a series of arms which are spring mounted, either on the back or often in the middle, that's used to measure the variance in the bore as it travels down the pipeline. So this is a fairly simplistic output from a fairly basic caliper type tool. So it goes down the pipeline and it gives us a pattern or a picture of what the pipeline condition is like. So the middle one is actually the best. So this shows us a fairly straight flat line with a series of peaks. So these peaks that are uniform and a consistent distance can be identified as being the circumferential welds, the weld beads. So this caliper tool has seen all the weld beads, some minor anomalies. That tells us that generally the pipeline is in fairly good condition with regard to the diameter and the ovality. When you've got dents, ovalities and various pipeline features, changes in diameter, where it goes through a valve manifold or valve station, there's characteristic signals which from a data analysis point of view can be read. Normally experts would obviously go through this information to confirm what there is. So that's typical of the sort of signals and the characteristics that you might see, change in diameter, dents. This pipeline here on the bottom, this line is pretty erratic. You can see a couple of the welds, but it's all over the place. So that means there's a few things going on here. There's either a lot of severe anomalies and or pipeline debris, because the geometry tool, it measures variation in the bore. If you've got hard pipe wall deposits in there, hard waxes and scales, and even loose debris, it will read that as being a change in diameter. So quite often the caliper will tell us what the pipeline is like from a piggability point of view, but it's also a good first line indicator that there's a lot of problems with dirt or debris in that pipeline. So here we know that cleaning is going to be a problem, because these aren't just normal anomalies, these are significant changes in bore right the way along the pipeline length. So that would give us a heads up and cause for concern. So a couple of different types of tool that are available. So as you can see, that one demonstrates how far down that tool can quite go. You know, it will reduce into quite small pipeline bores. And then the imagery that these tools produce as well. What I showed you before was pretty basic. This is a high resolution tool, so this is inspection data quality. So we've got a pipe image, so it's almost photographic. And you can see from a cross-section point of view, it measures the extent of the dent, so you can see quite clearly there's a dent here. And these are each caliper arm, it's moving the measurement on it. So the data that you get is really good, very accurate, high resolution, good coverage. It depends what you want to pay for as well, because you pay more for a higher resolution than for a lower resolution. So, but it does give you a whole load of information. So that's a better example of the dent there. You see, okay, so that's it from a FEA 3D modelling point of view, and then here you can see the extent of that dent. And then from here we can take the actual measurements, and that's, you know, that information you can take that away and do 3D modelling, finite element analysis, and decide whether or not that dent is an integrity issue or not, and then you might decide that that dent needs to be cut out or whatever. But you know, it's great technology. So we need to establish the internal level of the cleanliness. So the geometry tool might tell us or give us an indication that the cleanliness is a problem, as that did. So we can look at the current pigging data, run reports to see what's been brought out, what we know about it, or we can do a deposition measurement. So there are a number of tools that are used to measure debris or map debris in the pipeline. Again, there's high level and there's low level. So there's a very simple type of technology which is a data logger, and there's a more expensive high-end debris mapping tool. We'll talk about each type, but rather like the geometry run. If we've done a geometry run, then we can quite confidently put these tools into the pipeline straight away. If we're not going to do a geometry run, then we might need to do the piggability again using the foam pigs before we put these pipelines in. Because all of these technologies, as you'll see later on, are optional. You don't have to run a caliper and a debris mapping. If you prove the pipeline and you know the geometry is not an issue, you could go straight for the debris mapping. You don't even need to run the debris mapping, you could just go straight into a cleaning program if you're happy with what you know about the pipeline. So all of these things are kind of optional, a little bit, not subjective, but you would only use them where they're required. So the debris mapping tool, this will, rather like the geometry tool, it will locate and measure pipeline variation or bore, but in this case it's debris. There can often be two sets of sensors. One set is used to measure the pipeline geometry, and the other, which is much softer, to measure lift-off. So it can differentiate between soft and hard deposits. Questions asked earlier on, I think. Yeah. So some debris mapping tools can differentiate between hard and soft, some can't. And the great thing about these is if you've taken ownership of a pipeline or you're going to inspect it and it hasn't been pigged since it was constructed, if you run a debris mapping type tool before you start, you've got a baseline survey. Okay, so then you can implement and decide what you're going to do from a cleaning point of view. You know how much debris is in the pipeline, how it's deposited, where it is. You can decide what approach you're going to take. When you've started that cleaning program, you can run this tool again halfway through, and it tells you that you're cleaning the line properly. Yes, you're getting debris out of the pipeline, but you might not be getting all the debris out of all of the areas. Where the temperature is different, you might have much harder wax, and the tools that you're using might not be effective at removing that hard wax. So this will just tell you whether or not you're doing the job that you've gone out to do. So you can run it at any start, any time in between, so halfway or a third of the way through the program, just to confirm that what you're doing is actually working and the tools you've selected are right. And then once you've completed the cleaning program and there's no more debris coming out, if you run the debris mapping tool again, it will confirm that the pipeline is clean. There's no rubbish or pipe wall deposits in there. So that's your qualification tool with regard to technology and confirming that the pipeline is being cleaned effectively. So these are debris mapping type tools. So again, we've got sensors that are on the big body. These, compared to the geometry sensors, are a lot softer. So with the geometry tool, going back to the caliper, because you're trying to measure variation in the bore, the sensor arms have got very high spring pressure, so there's a lot of force on that arm on the pipe wall, because you want it to break through any crap or dirt that's in the pipeline. You want to get to the metal. With the debris mapping tool, you don't want to get to the metal, you want to softly feel the pipeline. So the spring and the sensor arm design and type is very different. So the caliper is very hard, a lot of pressure, a lot of force to get to the pipe wall. This is much more softer, touchy-feely. Okay, so the spring loading is a lot lighter, there's a lot higher degree of sensitivity. And this one here, I mentioned before, it's got two sets of sensors. So these little sensors here are on an arm rather like the geometry sensor, so this will allow you to differentiate between hard and soft debris. So if the debris is hard, like a scale for example, or let's say a hard wax, the front sensor will ride over the top of it, and the back sensor will ride over the top of it. If the wax is soft, the front sensor will ride over the top of it, but the back sensor will cut through it. So that tells you from the different characteristics in the signal that it's a soft material that it's measured, because one sensor's gone over it, the other sensor's gone through it. If both sensors go over it, it's hard. If one goes through it and one doesn't, it's soft. So it's in simple terms, it's not quite that simple because there's different sensor technologies, but the technology exists to differentiate between hard and soft, one or the other. And again, it's just a different sensor arrangements. So these are specific tools or pigs that are designed to run in a certain line of a certain size. Some operators or some companies provide these items that can bolt on the back, so that'll just bolt on the back of one of your pigs that you're running. So, you know, it's either a bespoke tool or it's something that can be added to one of your existing pigs as a modification. Okay, so that will measure the thickness, the deposit, where it is along the length of the line. It also measures a lot of other background features as well. So the temperature is recorded, the linear distance, differential pressure is recorded, so the pressure across the front and the back of the pig, axial loading, so if any vibration impacts that the pig might hit or see as it goes along the pipeline is recorded. There's also a gyroscope on board, so X, Y, Z. It knows its orientation when it's going up, down, left, right. This is all information that the pigging company will take and compare with what's known about the pipeline to confirm the pipeline condition and the amount of debris that's in there. Okay. That says it does not differentiate between hard and soft debris. That should say it does differentiate between hard and soft debris, depending on the type of tool it is. If it's a 2-sensor type, it will. Okay. So this is quite simplistic data. In reality, there's the reports are a lot more complex, but this is just a fairly simple. This is a snapshot that the company would give the platform once the tool's been received. So this is a quick overview. So in this particular line, you can see the red line along the bottom is the measurement of wax, So the wax thickness varies along the pipeline length from the start point for a couple of millimetres, increases to 3 or 4 millimetres, and here it ramps up to quite thick deposits of 8 or 9 millimetres where it drops back down and becomes more constant. If you look at the pipeline temperature profile, this blue line, it's kind of what you would expect to a degree. So what you're seeing is, this is an oil line as well, by the way, so as the oil temperature drops, wax fallout begins to occur as it reaches the clouding points. So there's a small, minimal amount of wax drops out of the products here, but once it gets to the fallout, the clouding point here, the wax fallout is quite high. So you've got a good temperature profile which correlates against the wax deposition. So it shows quite clearly, demonstrates that you've got wax in the pipeline and where it is along the pipeline length. So an output of that would be a range of thicknesses along the pipeline length, and it'll tell you the volume of wax in the pipeline. So there's 343 metres cubed of wax in that pipeline. So you know from the cleaning point of view how you're going to contain it, how you're going to get it out, how you're going to handle it, how do you control the rate at which you bring it out. Data logger, this is a little bit more of a basic tool, so it doesn't measure anything. It doesn't measure directly from the pipe wall. It just has a number of onboard sensors. So it has a shock logger, velocity profile and temperature, and it gives you a ride profile. Whilst it doesn't measure pipe wall deposition, it does give you a good indication of what's going on. So really speaking, this isn't a great shot, but basically the smoother the pipe, the straighter those lines, with the exception of the temperature profile, the better condition the pipeline is. It's a data logger would normally be run on operators will run them maybe sometimes every month or every quarter, just to get a profile, a general trend. These are fairly inexpensive to buy. You can buy one of these for a few £1,000s, bolt it onto the back of a pig, and it will tell you that the production pigging that you're doing is achieving a certain level because your pipeline profile is remaining pretty constant. The debris mapping tool runs, they can be as expensive as an inspection run. It might cost somewhere like £75,000 to run a debris mapping type tool. So it's not something you want to run all the time. So from a production cleaning point of view, if you're running a pig every few weeks and you're recording and reporting that data, by running a data logger every 3 months, it just gives you a trend, just gives you a visual image. And you might want to think about running a debris mapping type tool ahead of an inspection later on.
Just back to the previous slide where you said about the accumulation of wax in the pipeline.
Yeah.
How would you work out an aspect of receiving that wax on anticipation that you have a lot of volumes?
Well, you know what size your receiver is. Okay, so you've got a receiver and or slug catchers on the receiving station, on the receiving platform, so you'll know what the maximum volume is that can take. That pipeline said something like 240 metres cubed. I think it's a 10-inch line, so your receiver might only be, realistically, 10 or 15 metres cubed. So that's not going to handle all that debris. And because you know where the debris is, you just start off using pigs that are very low performance and often undersized. So it brings out a minimal amount of wax. So for a small diameter pipeline with such a high volume of wax, it could take several runs, and it could take 40, 50, 60 pig runs to clean that. So it's not something you can do very quickly, depending on the volume and your recovery rates. But the pigs can be sized to bring out a certain amount of wax. So when we look at the actually implementing a cleaning program, there's the data we've got to look at. So we've got all the background history. We might have already run a geometry tool. We might have already run a debris mapping tool. So we've got a good indication. So we've got two choices. So we can use mechanical cleaning pigs, utility pigs, standard off the shelf, or the more specialised cleaning pigs. Which one you choose is going to depend on what you know or what you don't know about the pipeline. Okay, so it's a question of taking all that information and any new information required and selecting the best pigs for what you want to do. Okay, so if we look at the standard off-the-shelf pigs, we talked about those earlier on, and we'll look at the enhanced cleaning pigs, the more specialised cleaning pigs, in a little bit more detail. So the methodology is determined by the approach taken, and then we'll use standard or specialised pigs or both, depending on how we set up the cleaning programme. So the standard pigs, we talked about these earlier on. These are off the shelf, relatively fit for purpose, for proving, cleaning operations, light cleaning, light duties. They're not great performers, they do the job, they're fit for purpose. And typical examples are the foam pigs, the batching pigs, the brush pigs that we talked about, the gauging type pigs. And we would normally pick standard pigs where we know it's safe to do so. So where we've got no concern. So we've got good data, we know what type of debris we're dealing with, we know there's no restrictions, we've got good history. So basically, the standard cleaning pigs tend to be used more for regular production cleaning operations or light pre-inspection cleaning. So we would use them in the early part of a specialised cleaning programme just because they're low performance. They're not the best cleaners in the world, but they are fit for purpose. The enhanced cleaning pigs are a lot more specialised. These are designed for specific pipelines, often in specific cleaning problems or applications. I'll show you some details in there. So if you compare the type of pigs, a brush pig, this is a standard utility type pig, so the spring mounted brush is relatively small. This is an enhanced type of pig, so the brush packs are much more densely made up. The brush is a lot stiffer, it's a lot more aggressive. And here you can see these brush blocks are very densely populated, very, very heavy brushes. And the coverage and the performance of these two pigs compared to this one will be significantly higher. So these will remove a lot more debris. And often with these type of pigs, what they'll do is they'll start off, they won't put all of the brushes on, so they'll take a percentage of the brushes off. So you might only have 20% coverage and build it up over a number of runs from 20%, 40%, 60%, up to 100% over a number of runs. So you're just managing the cleaning performance. The magnetic cleaning pigs, again, these can be more enhanced or specialised too. So we talked about the standard pigs, relatively small magnets. Here's a very heavy duty magnetic pig where the magnetic blocks basically form part of the pig body, so the whole body is basically magnetic. Okay, so this will pull out a shitload of debris compared to a standard pig.
So what flow rate would we expect for that bulk?
Well, the picking speed would normally from a magnetic cleaning pig, you want to keep it as slow as possible. So we'd be looking at a velocity of typically 0.5 to 1.5 meters per second, up to a maximum of maybe 3 for a magnetic cleaning pig. So you want it to move quite slowly to allow it to pick up this debris. So this might only pick up maybe small magnets. These magnets might only pick up a few ounces, okay, or a few grams rather of metallic debris compared to the heavy duty one, which will pick up several kilos. So you can see this pig's gone through the pipeline, it's been received, and it's just covered in welding rods. So that's picked up a lot of steel material. So there is a big difference again in the performance. And I mean, if this was running this is a gas line prior to running a PII till. This was for a gas company in Malta in Hungary. And this pipeline hadn't been inspected since it was built. So it was PII, we insisted that a magnetic cleaner was run. We brought out all of these welding rods, which had been left in the pipeline for, I think it was 7 years since it was constructed. So they've been sitting in the bottom of the pipeline for a long, long time, hadn't been picked. If the inspection tool had been run with that sort of debris in the pipeline, it would have been trashed, and that would be like the best part of £1 million tool wrecked, and somebody would have to pay for it, the operator. Scale and wax. So these pigs are a lot more aggressive, and these sort of pigs can potentially damage the pipeline. So scale and wax removal is normally managed by a specialist pipeline cleaning company. This is a pinwheel type pig. There's a number of people that use this type of technology. So you've got these steel fingers which are mounted on a polyurethane disc, And these have got a tungsten carbide tip, so it's a very, very hard tip, much harder than the parent pipeline material. And as you can see, this has left not actual grooves but polished lines. So if this is not sized correctly, if this disc is too big, if the diameter across these pins is too large in relation to pipe ID, it can cause damage to the pipe wall. And in extreme cases, I've seen this before, using this type of pig in a very, very heavily corroded pipeline, this actually resulted in pipeline failure. So this pig was so aggressive that where you had very, very thin pipe wall, so where you were down to less than 25% wall thickness, remaining wall, this pig actually went through it. So, you know, they are very, very, very aggressive. So you've got the pinwheel part for knocking off the scale, and this one's fitted with magnets on the front to pick up any ferrous debris. So this particular type of design, it's dual module. This is the lead pig, that's the rear pig. So this is towed at the back, so it's like a trailer. So, but what happens is all of the debris gets taken off the pipe wall, but it's left in the pipe wall. It doesn't bring it out. You've then got to put another pig through to push the debris that's removed out. So it's a two-stage operation. This is another pinwheel type of pig. So this has got steel domes or nuts on the back. Again, it's designed. This is actually a dual diameter one, which is why I've got these different disc packages here. So this is designed to remove hard wax, break it off, and these are brush packs which are angled to provide a shearing effect to again try and effectively remove softer waxes and scales from the pipe wall. This is another type of descaling pig. So again, this is pretty crude, but you've basically got steel, usually heat treated. So again, it's a hard steel series of arms just with a very simple blade. It's designed to break off hard scale and hard wax. But again, if this isn't sized correctly, this will cause some real damage to your pipeline. Real damage to your pipeline. So again, you've got to be careful when using these sort of technologies. And that's usually why they're only carried out by specialist companies. This tool is like state of the art. So that's kind of like, yeah, that's like your Land Rover, I suppose. By comparison, this is the Rolls Royce. So this tool is designed, when it goes in there, it's got all of these wheels and grinding and cutting tools on it. Okay, so this tool actually, it kind of almost machines the pipeline bore as it goes along. This is a company called Reinhardt, the German. No, sorry, they're actually Danish, not German, sorry. But the technology is superb. This tool will bring out the debris. So this uses bypass, it uses cutting, it uses grinding. It's a very expensive tool. They won't sell you these pigs. These type of cleaning tools are all only available for hire. A cleaning job using Reinhardt might cost £300,000 or £400,000 compared to a cleaning job with somebody else using something that's not as good but takes longer, might only cost you £150,000. There's a big difference in the cost, but there's a big difference in the results. But again, if this isn't sized correctly and run correctly, that'll take your pipe wall off, so that'll reduce the wall thickness. Very aggressive. So those type of tools are really only used mainly when we've got problem products, bad pipeline designs, and known issues with hard waxes and hard scales. Okay, not far off. Do you want to take a break just now, or do you want me just to keep on going? Push on. Okay. So we've kind of pretty much covered it anyway. So when we come to implement that cleaning program, we want to do something that's going to be progressive, it's controlled, it's going to give us good results, and it's going to give us the results that we can be confident in. So these are the 5 main stages. Now, depending on what you know or you don't know about the pipeline, you may or may not need to use all 5 stages. So you don't have to start with stage 1. If you know that if the pipeline's pigged on a regular basis and we know we've just got an issue with loose debris, we can go straight to stage 4. We might not need stage 5. If the pipeline's never been pigged for a number of years, or since it was constructed, we start at the beginning. So we go back to the basics, prove it using the foam pigs, gauge it to confirm the minimum bore before we can introduce metal-bodied pigs. We might want to consider the geometry type survey or the deformation type tool, so again, some optional elements. We could also include the debris mapping at this stage. An initial pipeline cleaning, so this is just using the lower performance of the utility type cleaning pigs to just have the first pass at cleaning. And then where we know we've got problems with hard wax and scale, the last stage of the cleaning is using the more aggressive pinwheel descaling type pigs to really rip out all of that debris. And again, the debris mapping tool would be used in the latter stages if we're going to use that for pipeline measurement.
Regarding the stage 1 pipeline proving, in case we have not the peak, such pipeline maybe 20 years, something like that, do we need to run the low density foam pig before medium density?
Well, depending on the line length, you'd probably start off with a low density foam pig, just because it's the lowest risk. And if it comes out in pieces, it doesn't matter. If it comes out intact, then you'd probably move to a medium or a higher density foam pig. And then if the higher density comes out in good condition, you put a gauge plate on it so we can put on the metal body pigs. But yeah, normally start off with low.
But what's the industry practice? Industry practice is just to run the medium density because the low density foam pig is very inefficient.
Quite often you'll start with the medium density, yeah. From a pre-commissioning point of view, you would use a medium density. But depending on the pipeline size and the line length and what you do or don't know about it, you could still use a soft, light foam pig. If you've got real concerns and real worries that there could be a significant dent in there or that the bore could be severely restricted, especially if you've got hard pipe wall deposits, a low density foam pig will get ground down or get worn down more readily, so it'll give you a good indication of the minimum bore. And it will also, because it's very buoyant, even in a gas flow, but more so in a liquid, it doesn't need to touch, doesn't need to seal, it'll still come out. So it depends. More commonly, medium density, yes, but there are occasions when you might want to start at a low. Again, it's based on what you don't know about the pipeline, really. It's down to the information that you have. Okay, so a typical progressive cleaning program then could look something like that, where we've got a couple of foam pigs initially to prove the pigability. Then we confirm the minimum bore using a gauge pig, a foam gauging pig. We know that we can put a pig of a certain type through there, so we'll put the conical cup, because again that's very flexible. We might run the caliper tool, which is an option. Then we'll start the cleaning, so we'll get the magnetic debris out, light cleaning using cup brush pigs, still light cleaning, then progress to the bi-dye brush pig, so increasing the aggressiveness that little bit more. Then we might start using the descaling de-waxing pigs. And we mentioned the coverage, so those pins and those fittings that are around those pigs, quite often they can reduce the number. So the coverage is, you start at a low coverage, 25%, cleaning between time, increase the coverage to 50%, and build up the aggressiveness. If you ran the pig at 25% and you brought out a significant volume, you know, if you're expecting, from a calculations point of view, if you're expecting to bring out 100 or 250 kilos, if you brought out more, then you wouldn't go onto this pig next, you'd stay at that level, so you'd stay at the 25% until you were happy that it was bringing out what you were expecting or what you'd calculated it to bring out. And then you just work your way through the program. So depending on the results of each pig run will determine whether or not you move on to the next type of pig or you stick at the same level. So that on its own is just the best practice. So what you would see here is, once you've proved the pipeline and you start the cleaning here, you'd see a certain amount of pipeline deposit, be it wax, scale, powder, the debris, will gradually increase as you increase the aggressiveness of the pigs. It'll reach a peak, it'll remain fairly constant, and then you'll see it drop off. Okay, and that's best practice. When it's dropped off to a negligible amount, it can be considered clean. However, the debris mapping type tool is a technology that you would use to confirm that it actually is clean, because although the pig's not bringing any hard wax or whatever it might be out, it doesn't mean to say that there's still not some left in there.
Excuse me. How long does it take to carry out the whole program?
Could be days, it could be weeks. It depends on the pipeline length. So if you've got a North Sea pipeline, it's relatively short. Let's say pigging speed. You might be looking at, if you've got a pipeline that's maybe 20 kilometres long, you could probably carry out up to 2 runs per 24-hour shift, because your run time is going to be at a flow rate of 3.5 meters, up to 3 meters per second. Your run time is going to be 6 hours or something like that, you know, relatively short. So you could do 18 runs over a 7 or 8 day period. If the pipeline is 150 kilometres long, then it might be 1 run per day, depending on your flow rate and the line length, or it might be 1 run over a couple of days. That the long run pig that I showed you before, the Yarcheng pig which had the yellow discs and the wheels on it, that pig took something like 38 days to run the pipeline length. So obviously that was 600 kilometres pigging at a certain speed, fairly constant, so yeah, a long time. Just depends on how long the line is and how fast you're running them at. But from a pigging speed should always be kept between, ideally 1.5 metres per second up to a maximum of 3. Once you get above 3 metres per second, which is still quite fast, then with the bush pigs in particular, the cleaning performance reduces because it's going too fast. They're travelling too quickly to be effective. And then you get bristle lift off and cut lift off and bounce. So ideally the slower the better.
Excuse me, you said it took 38 days just for one run.
Mm.
So to take only one run.
Oh no, they did lots of different ones because that was part of the pre-commissioning. So they'll have probably had 2 or 3 of those pigs together with a batch of gel or something like that in between time to fill the pipeline with water. So they'll have flooded the whole pipeline with water, then they'll have hydro tested it. There'll be valve stations where they could isolate the section, so they wouldn't have hydro tested the full 680 kilometres, but they'll have filled it with water using pigs. Then they'll have, as part of that, they'll have also gauged it. They might have run some brush pigs. They were brush pigs that we saw there. So I don't know what the actual programme was, but there would probably be somewhere between 6 and 10 pig runs. But some of those might be in a train. So in the commissioning stage, it's quite common to put 2 or 3 pigs in the pipeline at the same time. Operationally, that's not normally acceptable, but pre-commissioning you can do it. But again, it just depends on the line length and the pigging speed, the flow rates that you've got available.
Excuse me. If the pipeline passes through 3 countries, for example, or several countries, so the truck will start from the first country and end at the third country, yeah? It's going to be like that.
Yeah, it could be. I mean, they do cross.
Or every country has its
They
own
do.
part of traps and receivers.
There would normally be pigging stations, yeah. I mean, there are pipelines that cross boundaries,
Yeah.
but usually the ownership stays within the country boundary. So there would normally be a pigging station or a valve station at a border.
From
Yeah. So you would normally go from border to border because
you control your part, yeah?
yeah, yeah. So the pipeline might be owned by multiple partners, but only one operator might be responsible for the cleaning of it from his platform, let's say, to the border. Then it becomes somebody else's responsibility, but there could still be several pipeline partners or owners. So TACA, for example, okay, this is quite a good example. They've got multiple pipelines coming into Cormorant Alpha, so they've got 10 partners. There's BP, there's Shell, there's ConocoPhillips. So there's all these different partners. Then there's an export pipeline which brings everybody's oil from the Cormorant Alpha platform onto the Sullom Voe terminal. Sullom Voe terminal is owned by BP. Okay, the pipeline is operated by TACA, but it's owned by 10 partners. So when they're doing a pigging program, all the 10 partners have got to agree to the program. BP have got to agree that they're going to accept all of the shit, the debris, because again, we're going to clean the pipeline, we're going to pass crap down. That's going to be received at Sullom Voe, which is a tankage storage centre for distribution. So BP have to know how much is coming, because they need to know what they can do and how they're going to manage it. and they've also got to accept the fact that they'll take it, because they could say, we're not going to do it, we can't take it, or we don't want to take it, therefore you can't do that pigging operation.
More complicated.
Yeah, it becomes very complicated, it becomes very political. And again, the pipeline is owned by it's operated by TACA, it's owned by the partners up until the minute it hits land. So as soon as it hits land at Sullom Voe, the ownership becomes BP solely. So it's very complicated, very onerous, and there's got to be agreement with all parties. And you know, BP at Sullom Voe, they'll want to know what chemicals you're using, what chemicals he's using, because they've got to manage and recover and handle all of those chemicals. So things like, you know, your biocides, your corrosion inhibitors, everything that the operators put in on a daily basis, it's got to come out somewhere along the line. And BP is the company that collects it all. And they say, no, you're not using that, or we can't take that, you're not using that chemical, we won't let you do that. So they have a lot of influence on what actually goes on and when pigging programs and operations can run. So yeah, the more partners or the more borders or the more ownership, the more complicated it can become, yeah. But yeah, pigging stations is common on land where it crosses borders. So when we're talking about selection of pigs, one of the main things, obviously, the types of brushes and the types of cups are quite a key consideration for the cleaning efficiencies. So we mentioned earlier on the difference between using a cup, which is relatively low performance from a cleaning point of view compared to a disc. It has a disadvantage and it has advantages as well. So we can use it to our advantage if we want something to be of poor performance and not clean too aggressively. We'll start off using the cup pigs because we know they're not very good, but we want them to be not very good to start off with. We don't want to risk bringing too much debris in. The disc is very good, so obviously the disc pigs are used at the back end of the program where we've got confidence and we're cleaning crap out and we want to bulldoze it and we want to push it out. We want a big high cleaning performance. And also with the brushes as well, we saw there were spring mounted brushes. So the spring mounted brushes, whether it's a straight arm or a leaf type spring like that, they'll ride over debris, they'll bounce if the pigs are going too fast, but they don't tend to clean into corrosion pits. So if you've got corrosion already in the pipeline, the spring mounted brush won't actually clean into it particularly well, if at all, compared to the fixed brushes where the brush is either circular or it's on a block and it's fixed. There's no spring, so the bristle's doing all the work. So the bristle will clean the pipe wall and it will also clean into the debris. And there's a big difference in the cleaning performance between a spring mounted and a circular brush or a block type brush. So again, discs and cups and the types of brushes are a big consideration, especially in the general cleaning program. So confirming the cleanliness, we've gone to the extent of cleaning the pipeline, we've done this cleaning program, we need to be confident that it's clean. We talked about best practice, so we see the debris removal trend, it'll increase, it'll level off, and it'll decrease. Best practice, great. We can be confident we've cleaned the pipeline. However, there's no science applied to that apart from we've used the most aggressive pigs that we've got and now there's nothing coming out, therefore it must be clean. We can apply some of the technology that we talked about, so the debris mapping tool and the data loggers, when they're used as part of that cleaning program or in production, it just gives us a good picture and physical qualification that a pipeline has been cleaned. So we saw at the beginning it measured 343 cubes of wax in that pipeline. When we finished, we want it to say 0, or it might say 25. 25 metres cubed over that pipeline length is negligible. It's probably not going to cause any concern. You can be happy with that. So it just confirms that the cleaning has done its job. Once you've done it again, once you've gone to that expense for inspection or to clean the pipeline anywhere from the outset, you need to maintain it. So from an operator's point of view, we talked about the fact that we'll run pigs on a regular basis. So they also need to look at the data. So run pigs on a regular basis, do a run report. So the operator should be reporting when he runs that pig, when did he run it, how fast was it going, how long did it take, how much debris did he bring out, and he records that. 2 weeks time when he runs another one, he looks at the operating parameters, brought out 25 kilos of wax, great. 2 weeks later, it's brought out 25 kilos of wax. So you can see the trend. If all of a sudden it's bringing out nothing, or if all of a sudden that volume increases significantly, then there's something wrong, there's something happening, the pig's not performing, there's a change in the operating parameters, there might be different co-mingled products coming in, so there's a whole things that you can go away and look at and determine what the issue might be. It just allows him to identify problems or issues before they occur. It's also good practice, and there should be procedures in place, because you might receive a pig and say there's 1 bucket of wax. I might receive a pig and say there's 2 buckets of wax. Well, how big's the bucket to start off? You know, it should be a weight, so you should take the wax and you should measure it, or measure it, so you've got a standard measurement process, because quite often you see these reports and somebody will say 2 shovelfuls or 3 barrels, you know, or 2 buckets or 25 kilos, and a lot of it's just, it's speculative, it's not even guesswork, you know, you've got no idea what the actual volume is. So it's important that they maintain it by using the right pig, having a frequency. If anything changes, if they monitor that run and record the data and record the results, they can change the frequency as things change. But at the end of the day, they keep a constant level of cleanliness on that pipeline, because they've spent probably, to clean it and inspect it, they've probably spent £250,000, £300,000, which it might not sound like a lot of money, but it's a lot of money in time as well. That's just the physical cost of the actual work scopes. It saves them a lot of money in the long run just to run a pig every month or every 2 months, whatever it might be, just to try and maintain that level of cleanliness, because it maintains the integrity of the pipeline, especially with regard to corrosion, inhibitor, biocide and any chemical treatments that are ongoing. You also need to refurbish the pigs on a regular basis, so all the time they're running these pigs, it's like when you're running your car on the road, your tyres will wear over time and the performance reduces. Same with the polyurethane discs, same with the brushes, they all wear, so they need to be refurbished on a regular basis. Quite often that's done by the pigging companies on shore. We'll kind of jump the gun a little bit there, so we monitor it, so we do the periodic data acquisition. We can use the data loggers again, we can use the debris mapping type tool, we look at the reports, we do report analysis, we do debris analysis, keep the pigs in tip-top condition, and then we change the program to suit the trend. So it's all about trending and looking at it and seeing what it does, seeing how it's behaving and tweaking it up or down to maintain a constant level of cleanliness. So yeah, really the review of the procedures and the reporting system is paramount for production pigging, and also any production anomalies, trends and potential problems can be identified early and investigated. So to summarise then, with regard to implementing the production pigging programme, review the previous pigging history, so that's looking at everything, find out as much as we can possibly know to give us the best amount of information to start. If we don't know it, then we've got to find it, we've got to go and do geometry runs, do geometry surveys. Establish the level of cleanliness, so how clean is it before we start? That's what we use to gauge the methodology, the approach that we're going to take. Implement, decide what we're going to use and implement the cleaning program to clean the pipeline, confirm it's clean, then continue to maintain the cleanliness and monitor it on a regular basis. Any questions?
If there is a heavy dent on a pipeline and one direction pig was stuck there, how are you going to run it back if it's one directional pig? How are you going to take it out?
If it's a unidirectional pig, you can't. If it won't pass the dents, then you've got a problem. So there's other issues. It depends. Hopefully, we don't talk about pig tracking here, but if you know where that dent is and the location is, you can try increasing the pressure, decreasing the pressure. So one thing to do would be, if you decrease the pipeline pressure upstream and downstream, allow the pig to maybe try and resettle or reinitiate to re-establish a seal, then try and pig in it. It depends whether or not you've got bypass across the pig as well. So if it's got stuck and you've over-pressurised it and the cups, because cups will blow over as well, so it might be that you've got bypass across the pig, in which case that's another problem. So you can look at increasing the flow rates, increasing pressure, cyclic loading, so high pressure spikes, low pressure spikes, and this is done over a period of days. When a pig gets stuck, what operators will do is they'll take a big step back and have a look at the potential causes. They won't just go, oh shit, oh my god, let's increase the pipeline pressure, let's increase the flow rate. That's the worst thing you can do. the first thing to do is just take a little step back, have a little think about what techniques can be adopted, why it might be stuck, is there any bypass, what was the operating parameter of the trend, was there a pressure spike, try and identify what the problem might have been caused by, try all the different methods. There's different methods of trying to create a vacuum behind increasing and decreasing downstream and upstream pressures, cyclic loading, high pressures, high flow rates, recovery pig. So this is a pig that's used to go in behind it and push that one out. Try and locate it, but ultimately if you can't reverse pig it, because it's not reverse piggable, it's not a bi-die pig, then at the end of the day the worst case scenario is you've got to shut the pipeline down and cut that section out. Yeah. Shell had a problem which was only resolved last year. I think it was a 16-inch pipeline which was blocked. They put the wrong pig in. Okay, so they had a wax problem which was being managed with regular pigging, changing crew, put the wrong pig in, and ultimately it got stuck, and they didn't adopt the right approach to recover it. So again, rather than trying to take a step back, the shift at that time decided to try and increase the pumping pressure, which just made the problem worse. That pig was stuck in the pipeline for almost 24 months, so nearly 2 years before it was recovered. And then ultimately they looked at every possible technique to get it out. Reverse pigging, ultrasonics, so there's pressure pulse systems which can be used to create high pulse signals and ultrasonic vibration to disengage the wax. This was wax, to try and disengage the bonding of the wax so it could be pigged as a slug. Whole lot of different techniques, but in the end they had to locate it and cut it out, and they ended cutting up, because they couldn't pinpoint exactly where it was, they cut out, I think it was 250 metres of pipeline after 2 years. So that's 2 years lost production.
Wow.
Yeah, and then that's a vessel for however many weeks. It was probably a £3 or £4 million cut out and replaced cost. Massive cost to them, just because they got a pig stuck in the pipeline. And that was stuck because somebody, it was the operator. So the operator they ran their own pigs, they had a very prescribed schedule of practice, different crew, not familiar with the practice. There's a pig, we'll put that one in. Bang. So, yeah, totally. And then that guy probably went off for 2 weeks. So he's put the pig in the pipeline, he's on the fucking helicopter going home, not my problem. Well, there was a few people that did actually get finished for that. One of the Shell pipeline guys wasn't there for very long, because obviously he was responsible for managing the pigging operations, and ultimately, whilst it was an operator error, he was responsible for ensuring that didn't happen. So, yeah, he wasn't made an example of, but let's just say his contract wasn't renewed. So yeah, pigs do get stuck, and it does cause big problems. Yeah, big problems. So recommended reading is, I don't know if they're in the library or whatever here, but there's a couple of books. You've got nothing better to do on a night. An introduction to pipeline pigging. It's just a small little A5 type book. It's good. It's got some good information in it. And then All About Pigging is a much more detailed pipeline pigging operation with manual. Worth a read. That's basically it. So 4 o'clock. Just turned. No problem. Yep.
Like being a professional. I keep on being morning. You're by me last of my choice. No. Okay. That's for you. Enter the classroom as a diva. Make it by a knife. By a knife. If you are learning. Thank you. I want to die. Do you have any idea how to do that? I went straight to they're going to walk. A friend of mine told me that
Was that the big, in terms of cost-wise, was that the biggest that you know of?
What's that?
Like for a pig being stuck inside the line?
Probably the one I'm most familiar with, yeah. But there was a similar, PII, it was a job that PII were involved in a long time ago in Algeria, similar situation. It was part of a cleaning program that started off using foam pigs, but the wax pipeline was so heavily waxed that actually got foam pig stuck. And that was stuck for a while, but I think that's probably one of the most recent and worst cases. Yeah. Best part of 2 years it was blocked. Yeah.
Wrong pig.
Yeah.
I asked all the friends here. She's not even here, man.
Yeah, bad, isn't it? Like, how much it can cost you?
Oh yeah, it's crazy. I mean, there was an operator last year, BG, they got a pig stuck in the pipeline, but that was because the platform was shut down. And then because they were picking at such low pressures and it was a low temperature line, they had some issues with condensate build up, and then the startup process created problems with icing basically. So that pig was stuck for about 7 or 8 weeks.
I'm going on my first pig run this Easter when I with National Grid, because I was collaborating with them last year for my work, so they said that if I wanted to come and see one in action, then I can go.
So you're ready for?
Well, I'm doing this year, it's with Rosen, but last year.
Rosen, yeah. Alright, good, yeah.
So fingers crossed.
That's gas lines, isn't it? With, so you'll know Mr. Woodley.
Woodley?
Yeah.
I am being introduced yet.
Oh, do you know the guys? Oh, yeah. Doug, what's his fucking first name? There's a couple of guys. There's, I've got this Christian name. I worked with him for a few years. I was attacked as well. His dad's called Doug. Chris.
Okay, right, I'll keep that in mind.
He's one of the projects guys. And there's another guy, Lee, in the analysis side. I forgot his surname. I think one of the sales guys is Alan Brown. Yeah, they're a good crowd over there. Yeah, they're just up the road as well.
Exactly, beneficial, isn't it?
All right, nice one. See you later.
Can I ask you one more question?
Yeah.
Regarding your last explanation about that, the huge pig stuff, performance pig, was it the offshore pipeline? So that means they cut out the offshore pipeline.
Yeah, so there's a subsea section which
By hard testing.
yeah, they did. Well, they shut the pipeline down.
They didn't pick up.
They didn't. No, they didn't. They shut the pipeline down, and they did a hot tap, but not a hot tap bypass. It was actually it'd been out of production for a long time. So they did a hot tap, put isolations in place to allow them to cut the section out and re-weld it back in. Yeah. No problem. Thanks. See you later.
Because my company also have a subsidiary company in Abu Dhabi, which operate the one of our subsidiary connected to the TACA plant.
Okay. So who do you work for?
Dana.
Oh, for Dana. Yeah. Okay.
Actually,
Yeah.
It's our subsidiary.
Yeah.
I'm from Korea. So.
Okay. Okay. Yeah, Dana have got. Well, Dana obviously want to attack his partners. Yeah, Hudson ties in. It does. Yeah. Yeah. Well, the launches for the Hudson, because the Hudson's it's a subsea loop, so the launches for that are actually on the TACA platform. So when Dana do the inspection, they come out to the TACA platform, and obviously the procedures. They did that whilst I was with them. The procedures and cleaning that pipeline is problematic as well.
Really?
Yeah. Have a look. See if you can have a look at some of the historical cleaning data, because the cleaning and inspection of that particular system is quite not complicated, but there is issues from the cleanliness point of view. It's difficult line to clean. Yeah.
Because I'm researching about the Dana's Hudson pipeline for my dissertation.
All right. Very good.
Yeah.
Yeah.
With the inspection data.
Yeah. I think it's probably 3 or 4 years since it was last inspected.
2013.
Yeah, be about right, yeah.
Will
3
be
or 4
delayed
years.
for project
Yeah,
next year, I think.
yeah. I don't remember the guys. There was a chap. I don't think
So
it
the
was.
all the pig will be launched from Taka and then
Yeah, if I
down
remember,
to the
I can't remember. Yeah.
subsea receiver.
Yeah. Well, I think it's a loop, is it not? Is it not a loop? I think it's the manifold and it's a piggable loop.
I have not
I can't
seen
remember.
the-
It's a few years since
the
it was done.
detail,
Yeah. But certainly on that particular job, there was a third-party cleaning company that managed it. Obviously, there was the Dana representative. I don't know if it was the Dana guy, Bill Torrance.
Not now.
No. And then I can't remember the name. The pipelines guy. There's an older guy.
Don't know.
Yeah.
Neil? Oh no, Neil is young.
No. I can see his face, but I can't remember his name. It's a
Maybe
few
want to
years
change
ago.
it because there are high turnover.
Yeah. Well, as well, a lot of people, a lot of companies have made cutbacks as well, obviously, in the last 12, 24 months. So, yeah, he may have gone. I think the guy's name. It's gone.
So that the 24 months, the pig stop was also big company or just a local, the British, the local company?
What, from the pigging?
No, that the huge pig stop, that one.
Yeah. Well,
Was it
no.
a big company or?
No, it was the operator. So,
I mean the big operator.
the pipeline operator. So the
pipeline
it was
operator.
Shell. So Shell platform personnel.
Oh my
Yeah, yeah. So with the North Sea, a lot of the operators run pigs, so they run production pigs on a regular basis, every fortnight, every month, whatever. So yeah, so Shell will have been, they were running their own pigs. So the pigs will have been supplied. They have a company in Aberdeen that does
God.
the
What do you mean the
refurbishment.
long pig? Is it?
Run. So yeah, when you talk about pig run, that's the process of loading it,
Yeah.
launching it, sending it
Yeah,
down the pipeline and bringing it back. So that's what we class as a pig run. So it's the duration that it's in the pipeline. So the operator will, and in this case Shell, run the pigs themselves. So the Shell platform personnel will be responsible for selecting the right pig,
Yeah.
putting the pig in the line, launching it.
But what
So-
what exactly wrong at that time?
Well, it's a line. It's a line that has got issues with wax anyway.
Yeah.
So there's a wax problem. So as a result of that, the line had to be pigged on a regular basis using certain pigs of certain designs, okay, which had been developed to suit that particular application. Pigging was suspended for a period of time. So when the pigging is suspended, then the protocol changes. So you've got to then use a different type of pig because there's a gap. There's a longer than normal gap.
I see.
So there's more wax accumulation, so you've got to use a different type of pig. What happened was they didn't, so they had this gap in the pigging program. I don't know the details of how long it was, but basically the problem arose because they had this gap and they selected the wrong pig. So they probably just put in a regular production pig instead of one of the more special reduced, so probably a smaller diameter, probably had bypass or something like that, or jetting.
So pig stop because of the wax accumulation.
Yeah. So basically, the wax builds up in front of it to a point where the friction of that wax is such that the differential pressure isn't high enough to push it, and it stops. And they tried putting chemicals in from both sides, so chemicals from the downstream side to try and soften and dissolve the wax. So they put chemicals in and allowed it several weeks and months to soak to try and remove it. Then they would try pumping it again. They tried different technologies. There's some technologies which use ultrasonics and high pressure impulses. So they put it's high frequency, very sharp energy pulses, and it's designed to create vibration to disbond or disengage the wax from the pipe wall. Sometimes it works, sometimes it doesn't. In this case, it didn't. It's not a science as such. It's more of a black art. So they did try lots of different techniques, but ultimately they had to locate it, and even locating it was difficult. So they ended up removing. I think it was 250 meters. So it was a big section because obviously, if you're going to go out there and you're going to cut the pipe, you need to make sure that you bring the pipe and you get the right bit. But they didn't recover the pipe; they left it on the seabed.
How can it be? The government allowed that?
Yeah, probably because they've actually gone through it through the HSE, So they'll probably put plugs or capped the ends, so it's left sealed, contained. They'll probably be a management requirement, so there'll be it might be filled with a certain type of corrosion inhibitor or fluid, okay, and then they'll probably have to monitor that every 12 months. So there'll be blanks or plug ends, and then I don't know, it might be every, depends on the HSE. It could be every 12 months, it could be every 2 years or whatever. They'll have to go down and check the integrity of the pipe and check the corrosion inhibitors that are in there, check that they are still of a certain dilution, solution, it's still going to be effective. And they'll have to manage that for a lot of time. And the pipeline will probably only be recovered when the pipeline itself is abandoned. Yeah, so when they decommission the pipeline and abandoned it, they'll recover that section with...
very generous.
Yeah. Well, yeah, the HSE are quite good, but then again, Shell's a big operator. So.
And is it like for the pig signaler, for the pig tracking, is it possible to install for the offshore pipeline?
Yeah.
I mean, without ROV assistance.
Oh no, well, from a subsea point of view, you would need to go subsea with an ROV, but there's lots of different tracking technologies and location technologies. But basically, they mainly consist of putting a transmitter, ultrasonic or electromagnetic, or even just magnets, on a pig. So that pig has got a signal on it, so that's giving an impulse all the time. Then you can have a number of fixed points, so then you have detectors on the top side pipework, so launch and receive. So when that pig goes past and when that transmitter passes it, it records its passage, indicates that it's gone past. You could also put those in subsea positions, or on shore they put them in places where there's a road crossing or something like that, just to confirm that a pig's gone past a certain area or a certain complex. A subsea manifold, for example, if there's a manifold and tie-ins, there might be a pig signal on the outside, or on the upstream side, and one on the downstream, so it confirms, yeah, pig's been launched, it's past that point there. These would be hardwired back to the platform, obviously, by an umbilical cable, and it confirms it's passed and gone into the manifold, and it confirms it's passed and come out of the manifold. So they know that it's within a certain pipeline section, and these are kilometres. You know, these are kilometres and kilometres. So they know.
There is no technology, something like remotely we can monitor the location, exact location, like a GPS.
No.
There's no technology.
No. That's where the money would be. So what the pig tracking market needs is a pig transmitting system that can tell you where it is from a GPS point of view. The problem with that undersea is it's quite difficult. So you've got the pipe wall to come through and all the rest of it. And then obviously you need markers of one sort or another. So yeah, that would be some piece of equipment, and that'd be worth a lot of money.
If possible.
If it's possible. Yeah, but the technology's changing and improving all the time. So yeah, and if it gets stuck down there, as long as the transmitter is working, then you would go down with an ROV. So the ROV would have a receiver, and you just fly along the pipeline till you find it. Yeah, pinpoint its location.
Yes, actually, the contractor said when we had a campaign last year for our one offshore pipeline in Korea, because we worried about the pipeline, the peaking, because our post pipeline peaking after 13 years, and because there is a hydrate concern, so they said if we want to install the tracker there, maybe we need to think about the ROV. In case of stock, we need ROV to check the location, because there is no the marker in the subsea.
No. How long is the line?
Not very long, around 30. I don't know, 50, around the 50.
So there are markers, or rather indicators, passage indicators, that can be positioned subsea and left in a sleep mode.
Yeah.
So when the pig goes past, it triggers it, and then there's an indication system on it. But you have to go down with a diver or ROV.
Sounds very expensive.
Yeah, well, it's not that expensive. The expenses are going out there with the ROV and the diver, because you've got the vessel. So there are systems that you can put down there and leave down there for long, for extended periods of time, but somebody's got to go out, or an ROV has got to go down and check it to say that, yeah, it has actually gone past. But yeah, if you can come up with a system that when a pig goes past a certain point or a marker or whatever and can tell you where it is, that'd be worth millions.
And then regarding the question during the lecture about the low density foam pig,
Yeah.
because I have experienced when we run the low density foam pig for our condensate pipeline, the pig was actually not stuck, just stay still in the pipeline, in the middle of pipeline, because of the fluid passing. Because the low density foam pig very easily compressed, so all the flow goes through the.
Well, and a problem with the low densities as well is foam can become quite saturated too. And if it becomes saturated, then that can create problems with pigging and recovery. It loses its buoyancy and it can stall or stop in the pipeline. Yeah. But the low densities would be more commonly used if you've got something like a line that's got sulfates or scale build-up. Onshore, a good example of that is a slurry, cement slurry line, where you know that there's a certain amount of pipe wall build-up, and if you put a soft foam, if it's a 10-inch line, and you put a 10-inch low-density foam pig in there, and these are relatively short sections, these are 6 or 7 miles, so not less than 10 kilometres. When that foam pig comes out the other end, if it's 6 inches in diameter, then that can give you an indication of it's worn. It's worn to a very high degree, so that can give you an indication of the potential reduction in bore in that pipeline. Then you could put a medium density in, but we'd probably put an undersized instead of going with a 10-inch. If you put if a 10-inch soft went in and it came out at 6 inches, then you probably wouldn't put a 10-inch medium density in. You'd probably put a 7 or an 8-inch medium density in, a smaller one. And you would expect that to have similar damage, so that might get some shaving. And then that kind of gives you an indication of where the internal bore sits. And then you may want to get heavier density in your gauge pigs. A lot of it, with the foams,
I saw that in normal case, the pigging company doesn't recommend the low density foam pig.
Because from an operational point of view and an application point of view, they're not any good. You know, they're very poor. They're poor performance. They don't really do anything. But the advantage is they'll break up and they'll wear down. So there are occasions when you would use, but 9 times out of 10 you start with
because of that, regardless of that there is a debris or the pipeline, the bore reduction. Every time we run the soft foam pig, it comes out as broken. So.
But it comes out.
But it cannot tell nothing, anything. Always broken.
Okay, so depending on what size that is, it might be worth considering a medium density, but of a smaller size. So, try a smaller, because a foam pig's going to come out anyway because it's buoyant. It doesn't need the seal to drive it. It will come out unless you've got offtakes and branches in there. So you can kind of, experiment is the wrong word, but you can consider different options. If you consider the potential risk, is it going to come out? The risk is high. It will come out. Yeah, the probability is high. So you might want to consider a medium density of a smaller size than you would normally put in, on the basis of the condition of the low density that's come out. So pig manufacturers, the pig supply companies, they probably wouldn't recommend you run them anyway, regardless. But from a pigging service company would look at it differently, because they would see, although it might come out in bits or pieces to you, there is some value in them running that and seeing that, because from that they can determine certain situations or some parameters, and they can make it adds qualification to the next decision. So the more information you get, the better. But again, it varies a little bit. From an operations point of view, I'm not a big fan of using foam pigs, but there are a number of operators and a number of people that like to use foam pigs. But to me, it's poor performance. There's no real value in running a foam pig.
Actually, the value for proving.
That's where the value is, proving, absolutely, proving. Yeah, that's where the value is with foam pigs. But like I say, there are operators that will. Quite often overseas, I don't know why it is, but in the Middle East in particular, they like to run foam pigs and they like to run just conical cut pigs. So
I saw that I saw the BP, one BP platform in Vietnam, they run the spear foam pig, the regular base, for cleaning purpose.
yeah, just foam pigs.
Yeah, spear foam pig.
Oh, the sphere,
Yeah,
a foam sphere.
yeah.
Yeah, you can get foam spheres, but again, spheres were, for gas lines in the UK, they were very, very popular.
Mm-hmm.
You know, a lot of pipelines were pigged with them, and then the operators moved away from them and went for bi-dyes because they were more effective for liquid removal and,
Mm-hmm.
and condensate management. You know, they're much better.
Mm-hmm.
And people do still use them. There's a few European RMR and a few other companies that still use them for fuel lines, you know, so where they're putting different grades of fuel through, they'll use them as a
But why
barrier.
only Southeast Asia or some foreign country? Because all that the pigging run done by like Logen or 3P or
Yeah, well, a lot of it, it's funny because a lot of it's historical and a lot of what an operator does is just based on, he's done that for the last 25 years
I see,
and he won't
yes.
change it. You know, they often don't see past the fact that we do this
Mm-hmm.
and it comes out clean, we're happy, it's not a problem. But, you know, the conical cut pig is a good example. I worked for T.D. Williamson, and T.D. Williamson used to sell a conical cut pig with bushes on it, and there was numerous, what was it? Adnoc used to run these all the time. And you'd go and do the inspection and they would say, well, we don't need to clean the pipeline because it's clean. How do you know it's clean? Well, because we're running these pigs and they don't bring any debris out.
Mm-hmm.
They don't bring any debris out because they've been running the same pig for 6 years and it's worn out. It's not touching the pipe, you know, it's not cleaning, it's not doing anything. So then you do the inspection and all of a sudden you've got tons of dust or sand, you know, and it's a big problem because there's this concept, there's this view that they've been running this particular type of pig. It's maybe not very good. They don't do any refurbishment. They just run it and then they change it maybe in 2 years' time, and that's it. So they're not. It's not adding any value. They're meeting the criteria with regard to any KPIs that they might have and all the rest of it, but from a performance management point of view, it's often not doing anything.
KPI, just the number of run
Yeah,
or year or something like that.
Yeah, well, it is, yeah. I mean, TACA have KPIs for all their pipelines, so if the KPI is, depending on the line, it's 12 if it's run monthly, obviously, and then if you at the end of the year, if they haven't run 12 pigs, it's, I mean, obviously when we were there, we knew why they weren't running pigs, but the KPIs were as basic as that. They weren't referring to the performance, so it didn't matter whether it was the same pig around 12 times or whether it was 12 different pigs. The KPI was achieved, but what they weren't measuring until we started looking at it was the actual trends, so the performance. Is that pig the right pig? Is it working? Is it doing what we want it to do? Let's look at the data. Well, you know, for the last 6 years we've been running these pigs and they've only been bringing out 5 or 6 kilos of wax or debris.
So the most of time for in this country like UK, the continental shelf for the pigging campaign, so normally the cleaning pigging are done by operators and then no specialized company will review the result of their run.
No, normally,
Not like that.
no, not normally, no. So normally, so an operator will do a production, regular production pigging. They'll have records. They may or may not assess them. TACA we did, so we used to look and see if there's a chance. But then quite often what will happen is before they come to do an inspection might be every 5 years, 7 years, it could be anywhere between 5 and 10 years. So they'll run these production pigs, and in August of this year we're going to do an inspection, let's say, okay. So as an operator they might say, okay, well, we'll continue running these production pigs on a fortnightly basis, but let's get one of the cleaning companies to have a look and see what they recommend. So they'll then give a cleaning company access to all the engineers. So, what do you think? And they'll say, oh, you need a cleaning program. You know? Well, a lot of the time they can do it in-house. At TACA we used to do it in-house. So we look at the data. We're going to do an inspection in August. Okay, so we'll increase the frequency from every 2 weeks So every 3 days for the 6 weeks before we plan to run the inspection too. And we'll use this push pig and that push pig and that push pig. You know, so you introduce your own cleaning program, but the operator does it himself, and that's quite common in North Sea. It's mainly the operators that don't pig on a regular basis that would bring in a specialist cleaning company to clean the line before the inspection.
The cleaning pig company is the same as inspection pig company?
No, not always. They're often different. So some companies will do cleaning. PII used to do cleaning, and they still do some cleaning, but they'll tend to do, let's say, safe cleaning. So if it's a low risk pipeline that's in pretty good condition and it needs a little bit of a clean, then they'll do it. Because from a contractual point of view, if the inspection company cleans the pipeline and the inspection fails because the pipeline is too dirty, the inspection company is then going to continue cleaning at their cost. Run the inspection tool again at their cost because they're doing the cleaning. So it's actually in the inspection company's interest for somebody else to do the cleaning, because if the inspection fails, they can say to the operator, pipeline wasn't clean enough. And by the way, that's £100,000, thank you very much, there's invoice. Then the operator then has to go back to the cleaning company and say, you haven't cleaned this pipeline. So it takes the risk of the inspection company. So it depends. PII used to have a specialist pipeline cleaning division, and they closed it down because the risk on them was too high. It was better for them to subcontract, or rather it was better for the operator to have somebody else do the cleaning, and if it wasn't clean enough, that was a separate contract and a separate issue. The inspection company would still get paid. You still do the inspection, it's failed, the line's dirty, we didn't clean the pipeline, here's our invoice, it gets paid. But then the cleaning company, he's the one who's not getting paid, and he's got to clean the pipeline, he's got to clean it and clean it and clean it, and the inspection company comes out again for another £100,000 or whatever to do the inspection. So it's in their own interest not to do the cleaning. But on some of the bigger contracts, there's a chap there, he's doing some work with Rosen. Rosen do a lot of the Transco, so they do a lot of the national grid gas pipelines. They do run, as part of their contract, they do run cleaning pigs.
Only for low risk?
Well, it's low risk, yeah, it's very low risk. And there'll be a clause in that they'll run. So they'll run, probably, there'll be a basic programme, so they'll run 1, 2, 3 pigs of maybe a certain type. So they'll do 3 pig runs, and then there'll be a collective decision making point between the inspection company and the operator to say, these are the results, Mr. Operator, we think the pipeline's clean. Are you in agreement? So both parties then sign off. And if Rosen say, oh, we don't think it's clean enough, and the operator says, yeah, I think you're right, it's not clean enough, do some more cleaning. Then they can do some more cleaning and invoice for it. Okay? If Rosen say, we don't think it's clean enough, and the operator says, yeah, it's clean enough as far as we're concerned, do the inspection. If the inspection then fails, because it wasn't clean, and the operator told them it was clean enough, then the rerun cost is back to the operator. So it's all contractually, cleaning is a bit of it's a devil, really. Yeah, it can be very problematic.
I only have experience for the inspection run and the cleaning run done by the same company. So in that case, at that time, the inspection run failed, because actually it's not because of the poor cleaning, it's because of the tool failure.
Okay,
actually
so
the
something with the
seal
tool.
was melted by the condensate, so they rerun, so all the cost paid by the inspection company.
Yeah, that's often the case.
I think they thought that it was low risk pipeline, but they chose the filling material for the UTP.
Yeah. Well, that's a risk that they take. Yeah. Very good. Okay, excellent.
Yeah.
Okay. Do you need to put the lights off or anything in here? Yes.